Okay, wait, I am audible. Okay, so first off, Torch Nova, thank you for the Prime sub and for 7 months. So, we are continuing to work on the card cloning today, but a minor issue. So I was trying to get it set up to have my laptop at the desk over there so that I could like not kill my back standing on the stool that I have over here all day. And I forgot to reinstall Nginx and RTMP before or since we did the Threadripper build, and for some reason I can't get it working again. So I really don't have a way of doing video capture from the laptop while it's over there, and that's proving problematic. So if you want to bear with me for a moment, I'm going to try and get that fixed. The stream was just a minute or so late because I was trying to get that working and I couldn't. I don't know what was going on. Anyone getting dropouts? I have not dropped any frames according to OBS, so I don't know why you'd be having issues with that. But yeah, so if you want to give me a moment, I'm going to try and figure out why I can't get RTMP working. I shouldn't have touched that. It's got grease on it, so it stops trying to strip all the metal. Yeah, so do I have to fix all the things. Yeah, that's the thing. I got Nginx installed. The laptop thinks it's connecting to it, but OBS here can't find it, and neither can VLC. So it's almost like there's an Nginx configuration issue where it can receive the stuff, but it can't publish it, HDMI to VGA on laptop. So the thing is I'm trying to do multi-monitor today. I'm trying to use 2 monitors, so it's also not really incredibly difficult to have everything visible. So that's really complicating it. Elsewise, I'd just run my long HDMI cable over there. So that's the problem. Hello, Dogface. But yeah, I may just have to give up and remove the second monitor. So yeah, I'm gonna try the super awesome security setting of allow publish all here in Nginx and see if that works. Maybe it's just trying to not allow all clients. Reload Nginx. Okay, Nginx status. Boom. Okay, says it's working. Laptop has green square over there, which to me makes me think that it's successfully sending video. Let's see, VLC. All right, so theoretically, I should be able to open network stream here. 127.0.0.1/live/laptop. Okay, play, and oh, it's working. Okay. All right, give me a moment here. I might be able to add this. Add media source. Oh, well, that's going to be really mercifully easy if I get this fixed within 5 minutes of the stream starting. Okay, add an OBS scene. Okay, RTMP://127.0.0.1/live/laptop. Okay, and yes! Okay, we're good. Oh, whew! All right. So I will throw that. What did I move? I moved the wrong thing. This into there. Okay. And now I can hide or show. Well, why is that being weird? Oh. Oh, that doesn't hide like that. Well, okay, I can work on that still. So anyway, okay. There we go. We got it working. Okay. Blah. All right. So, okay. There's not really much to go over introduction-wise here because we're just working on the same thing as yesterday. I can head over to the laptop and start to fill you in on some of the stuff I was working on, and I'm going to make one change here right at the beginning to the GitHub repo to solve some things. There's a better way of solving this problem, but I'm not well versed in it, so I'm just going to ignore it. So I can go to that to show you stuff. Oh, the phone's not plugged in at the moment. Give me a second. Actually, I guess that cable could reach. I was gonna plug in a different cable, but you know what? That's not that far. I can just plug in the normal cable. Oh, there we go. All right, that is running. I think the deck talk's working, so everything should be good. Okay, I will re-show capture. All right, and then I'm gonna switch over to that camera and whoa, success. That's kind of hilarious to sit down at a computer and like answer the phone. Like that is a special kind of weird. Okay, so let me just bring up Twitch chat here real quick. Like neither monitor is safe. You know what, just give me a moment. Let me, just in case something shows up here, I'm gonna hide the laptop capture for a moment. How far did you get in the design? Had to leave early and still working in KiCad. I mean, yeah, KiCad is the schematic capture software. Oh wow, that RTMP is so far behind, holy moly. Unfortunately, that's just how it's gonna be. It's the only way I can do the multi-monitor capture stuff. What am I doing? Oh, I'm hiding it. That's right. Boom. Hide. There we are. Okay. Just give me a brief moment here to get that set up. This is far enough away that it's not going to be a problem. Just a fun fact here. So this is a 1080p monitor. This is a 4K laptop display, and it was going to be an utter nightmare to try and keyboard, seriously, there we go. It's going to be a nightmare for scaling going between the two. So I configured the oh my gosh, the NVIDIA X server settings to have this render a 4K display, but then scale it down to 1080p. So the scaling's actually correct, but it's really terrible. So that's a thing. There we go. Now I can see Twitch chat on here. There we are. Okay, now let me adjust this so it's not as annoying. Or I'm trying to set it up so you can kind of see the middle of this when I'm working on it. So I'll go over this somewhat, and yeah, I think maybe what I could do is just crop the left side of this a little bit, because realistically the whole thing doesn't need to be seen. Maybe it's some of the like that. So I think that might be, oh wait, you can't see it yet. One moment, let me go bring that back, because I've got chat running now. Broken Code, thank you for the Prime sub and for 6 months. What am I doing here? Bringing capture back. Boom. Oh, wow. Really? It went to like the one thing I didn't want it to show. Okay. That is so far behind. Why is it so far behind? Okay, let's get rid of all network buffering. Okay, how about that? Is that gonna work? Or is it gonna be dead now? Please work. I'm hiding and showing it. Ruh-roh. Let's just go to this view for now while we... Ah, okay, now it's... Alright, sure, why not? Okay, let's go to that. Alright, I think we're good. I think that view works. This is kind of blocked by chat, so I'm going to slide that over just a little bit. Alright, we're going to try and go with that. Okay, why not run the laptop in 1080p? That's a fun thing. So, JJ2112, the laptop can never run in 1080p. The panel only accepts 4K. It's kind of really stupid. I can open the NVIDIA settings here, and then you'll see how weird this laptop is. So if I go to display configuration and look at this one, and I try to change the resolution, it shows all of them as scaled. So it will always output a 4K signal, but it can like render a lower resolution canvas and then stretch it up. So it's always 4K no matter what. So it will just look weird like that. Yeah, it is. It's really strange. There was one time in an older driver version, it let me send 640 by 480 to the panel, just raw, and it almost killed it. So I've learned not to do that. So yeah, all right. So there's that. How long does that take to minimize? That is about 3 or 4 seconds. Okay, that's not the worst thing, but yeah. Okay, so let me go over this. So when I move, yeah, you can mostly see that. Oh, it didn't. It hid this. Let me make this force to be on top. Hold on. Keep above others, and then I will just move this over. Okay. Killing an LCD panel is never fun. Yeah, definitely. The one in a laptop's not fun either. Okay, so here's the card. I have been doing some more work on the traces and stuff, so I started following some traces around and marking them. I got the data bus for the 595s pinned out here or marked. So I'm going to be going with this as my, I think I know what it is, 99% sure line, which, you know what, I should probably copy that. What was it, A2 down here? Yeah, it's that one from context that goes SA0, that's it. Okay, so let's put that, where was it, A0. It's pin 1, or is it A4? No. A4 goes to, should be 705. Okay, I have it marked as not sure. Okay, that's good. So the thing is that what I'm doing here is green traces are ones that I've already, yes, I assume Helencroft. The thing is that I mentioned this on Discord. The 8251 obscures a lot of traces. There's a lot going on under it. So for the record also, for those of you who weren't here yesterday, the red traces are actually the bottom side. I've made an image that is the bottom side of the card, and I'm using the additive overlay mode to have just the bright traces be put over the top side of the card, and I've tried to align them. So that's a thing. And then I have a drafting layer where I'm marking all the traces green as I add them to the actual schematic. And then anywhere I'm making guesses, I'm currently making it yellow. And then when I'm planning stuff through, I'm making it purple. So I'm actually gonna go up here, and I'm gonna add purple through there. So that could be interesting. See, that says G and D for that. So those pins are ground. That doesn't make sense. We determined there's only like one ground down here, and it was pin 8. So why are there so many grounds for the 16 pin connector? Well, we'll have to figure out that. That one is 100% sure ground. So why are those connected to ground? That's weird. Well, we'll worry about that later. So what I was gonna say is that if I come up here and I grab, why can't I edit the color? Paintbrush, color, what? Oh, it's under the chat. Weird. Anyway, I was gonna say, let's do this. So this is a ground trace. This almost certainly cuts straight across like that. So it's probably safe to say that pin is grounded. That pin is grounded. I don't know about those two. That's a little weird. It looks like there might be enough room there for those to not be grounded, but I don't know why it would be there if it isn't. And that one is like extra confusing. So there's that. Then down here, there is a power 5 volt, and it would connect through like that. No, or no, that one's ground. Okay, yeah, that one's ground. That one's 5 volt. So this one would be ground. That trace would be ground. So we would need to figure out what that is, potentially that. So there's a bunch here. So like these might be connected. That doesn't really line up with anything. That doesn't really line up with anything. This maybe lines up with that. So there's going to be a lot of guessing here. I suspect I'm going to have the person who sent me the images here do a lot of probing on this chip to try and figure out which traces are going where, because it is very difficult to tell. We might be able to say this trace goes to that, and then maybe this goes to that because I had to jump over that. That one might go to that. So we don't know that one still unless it's just that. This might be that. I don't know what's going on with that one. Let's look at the top side. Well, that one clearly just goes directly into that pin. So yeah, that part's really complicated. We're going to have to make a lot of guesses on that chip. So that's fun. So, but for right now, I was kind of working my way from the bottom up. I really don't know what's going on with this connector. It's not going to be fun. So I've been kind of avoiding that until I got more done leading into the chips, the buffer chips. So yeah. So how far behind is that? Something like maybe. Oh man, it gets so far behind. It is a lot like Sudoku, actually, David. That's not a bad analogy. All right, I'm gonna do this. I'm panning the schematic significantly right now. I want to see how long it takes to catch up. It's not too bad. All right. Label DB15 on the schematic according to the documentation we have. You know what? That's not a bad idea. We can do that. So let me bring that up. Also, yeah, I was gonna say, here's how. So I haven't committed this to the repo yet with the updates. So I decided what I wanted to do is I wanted to come in here And I was just gonna kind of pull this file out. So I'm gonna go ahead and save this. I'm gonna pull it up. All right, or you know what? Maybe I should just git ignore it. Let's do that. Create new text file dot git ignore the name. Start with this dot. Yeah, that's fine. Okay. And I want to ignore this file, and then what I'm going to do is I'm going to export two images. I'm going to export the X-ray view and then the overlay PNG of all of the traces, and then anyone can just rebuild the image as I work on it. Can you git push it via CLI? Yeah, I should be able to, Wolf. So I can't right now because this file's enormous. It's 122 megs because I have a bunch of super high resolution images all stacked on top of each other. I was trying to get this size down. The only way I could possibly do that is if I go in here and I just delete the reference group and then I save it, then boom, it's only 52 megs. So actually, you know what I should do? Hold on, let's do this. File, save as, X-ray, save, okay, undo, just delete that group, and then probably that too, and then file, save as, stacked ref, save, replace. All right, there, we just split it into two images and both of them were small enough. That'll work. Oh, git, oh no, I just use regular git. That's what I do. All right, now I can just use this. Problem solved. Who needs large file storage when you can just have more file storage? That'll work. Okay, now I can do git add dot do takes it a while to copy it. Git commit more traces, and we're about to try a push. Git push. This should work. Not watch my. Yeah, that is a thing. Hardly Bogan. The word git does get reused there. Yeah, so Wolf, maybe you just want to try plain git, because this seems to be working for me. While that's going, let me bring up the LMSI pinout file. Maybe. You gonna show that there, Gwenview? This isn't on like a network storage or a hard drive that's going to be bottlenecked because it's doing the git stuff. Why is this taking forever to load? I guess git does mess with files. Maybe I should just wait until after that finishes. Also, Gwenview's been sucking, so you know what? Maybe that's it. Maybe I should just open it GIMP in the background. Yeah, you know what? Pass. Open GIMP. 3, 2, 1. Boom. No. Why? Really? I'll wait for that to finish. Cause yeah. All right, well, over here, I do know some of these, so let's just add some labels. So we have maintenance, you know what I think I might want to do is edit that, say 1, because if I don't do that, then, ooh, hold on, I have an idea. Yeah. That almost worked. I was getting there, Helen Croft, but it didn't. I got an idea. Hold on. Let me do this. Delete. Label. M1. Boom. Haha! Okay, that's cool. Now I'll just do that. 1, 2, 3. Ooh, fancy pants. That's cool. All right, so those are the maintenance ones. Those are basically no connect. What machine is this card for? IBM, Commodore? Trains in the Attic. This is for an IBM 5150, pretty much straight up. It would be at home in a 5160 as well. But it is an 8-bit ISA card, so it's just those two systems basically, because like the AT would have 16-bit ISA slots and it would have been designed differently. So this is really meant for a 5150 type system. Failed to push some refs. Ooh, Git might be... Oh, large files detected. Huh. What did it... Stack ref is... It is not that big. What? You know what? I'm going to rename the file. Card sides. Boom. Git add, git commit, boom. Git push. Maybe that'll fix it. Because there's no files over the GitHub size limit now. Yeah, David, Bluetooth headphones definitely suck. I can't... Wait, GIMP crashed. What? No, not quite. Why can't I... Well, the keyboard's working. Why can't I zoom in? This is weird. Close. Computer, what is your deal? Wait a minute, is there a window open under... No, not under the chat. What is going on? I can resize the window, but I can't click into it. Alt F4. No, escape. Oh, what? Oh, I bet this window was open somewhere. Stupid. All right, now it'll work. Yep, there we go. I can do all the things again. All right, bleh. Okay, so we got ground. We can kind of just leave that one, I feel like. So I'm gonna move that. Boom. All right. Now, 13 is attention minus. I'm gonna go kind of full names on here, so I'm gonna make these kind of long. Oh, wait, I should start from the top. Oh, yeah. Kind of sucks there's a 3-second delay, but at least it's not that bad. So is there anything in this card that isn't made today? Is this like the mini pet where the only chip that isn't made is the video chip? Every single chip in on this card still exists today. So if I show you just the top side here, these are all... It's still got me! Okay, I'm gonna have to figure out a command to like delete all records of that file from Git, because it's driving me crazy. So yeah, everything on here is still made today. This chip might be hard to get comparatively, but it's still an off-the-shelf UART chip. But everything else is just 74 series logic or like 26 series logic. So it's very, very simple. All right, how do I like totally expunge a file from Git? Probably want to make this, could probably make this card with all SMD parts. Yeah, I could probably, but again, I'm going to go with the clone route. I'm going to try and make it as close as possible. Git completely remove file from history. Okay. So the CD drive itself is mostly like that too. I don't know about that. Philips did make their own ICs, and the CD drive definitely has a very early and difficult to get transport. So I wouldn't say that. Matter of fact, CD drive has a really cool thing that I didn't show yesterday going on. This is how early it is. The laser transport is radial, not linear. So it rotates kind of like a tone arm on a record player instead of just moving straight forwards and backwards. Once I can make a video about it, it's going to be really cool, but I just can't without the thing working. So, yeah. Okay, let's see. DigiKey still carries AMD branded? Wow, Tater's game, that's awesome. So I'm going to be able to get like the totally original part. That's hilarious. Let's see. Dreaded Windows Update messes with the audio settings. Oh, that's annoying. Okay, so I'm going to try and use this command here. Let's do that. I'm going to get the file name. Copy. No, copy. Okay, I'm going to have to put this in a text document, I guess. Copy. Kate. Paste. Let's not do the stupid secondary line. Save. Okay. Oh, you know what it might be? Let me connect to my server. I get weird file issues when I don't connect to the server. That's what it is. Yeah. All right, so looks like we've maybe fixed it. Okay, then I just do a push. Found it here. Warning, this creates a ton of commits and causes divergence. You probably have to force push after. I was too scared. Oh well, git push. Boom. See what happens. Let's see. Updates were rejected. Is behind. Integrate. Git push. -- force. I'm breaking all the things. Oh, I guess I could be doing this over here so you can actually see what's going on. I'm trying to fix the GitHub repo because there was a file that was enormous in there, and GitHub is saying no thank you. Oh, is that a Technology Connections video you linked, Towncroft? Cool. I don't know if I've seen that one. I watched a bunch of his videos about the CD stuff because I was similarly pulling out my hair with CDs because they're the worst thing ever, but mostly from the aspect of ripping. Wonder if this upload's gonna work. It would be nice if it finally is functional. Ah, I think it did. Okay. Let's do this. Code. Boom. Card sides. All right, it's updated. Excellent. Okay, so the current version of this is now up, and I should be able to push the newer ones a lot easier. EDA. Excellent. Okay. All right, I should be able to delete the CM-153 folder from the EDA folder, but we'll do that later. Okay. We can continue with this. All right. Label. We're going to go response plus. Okay. Boom. Label. This is 9. Yep. Response minus. Command plus. Command minus. Data plus. Really like DigiKey has gone to chip broker route with these things. Wait, what? Does DigiKey not directly ship some of their stuff now? I haven't encountered that. I also have a confession. I don't know when the last time I placed a DigiKey order was. I have not done it since COVID. It's actually been a really long time. This project is going to be the first order I've placed since ATX PC Junior stuff. No, actually since Coleco Adam stuff. That's right, I did that. Tension. And that was the wrong location. Minus. Move. There we go. All right, so there's the pin out, and because we're doing that by pin number, that should be good. So yeah. Well, Jout, I feel like one of these days I want to do something like that, like just do a really big order of like a bunch of generic stuff, but I also really like the idea of always trying to match as close as possible, so I don't know, I'm torn. Okay, so I'm gonna go ahead and save that. Just for giggles, I'm going to try a little mini git push here. Git nano label LMSI connector. Just want to make sure that it's actually like working. All right, perfect. All right. I really need to use Stadia technologies so that your RTMP happens before you do step. Yeah. I tried to get NDI working before the stream. You know what? I bet the laptop's still outputting NDI, actually. Yeah, see, tools. NDI output settings. Okay, so I have it set to output NDI, all right? But I can walk over to the other system. You guys aren't really... Well, you know what? I can do this. Hold on. C... And then I will just hide capture for a moment here. So if I try and add an NDI source, boom, okay, create new NDI source, all right. Source name, never finds it. It can't. So if you remove the space between plus and minus, kcat, oh, that's cool. So yeah, it'll never find it. I can try and type it in manually. It still won't find it. NDI kind of works as like I don't know, it's kind of like the machine names on a network. It only works if it can actually find it, but for some reason it's not able to find it. You can't just put in an IP address, from what I've seen. So, and yeah, that is kind of cool looking. So yeah, tried to do NDI, which is supposed to be much, much lower latency, but it did not work. So, isn't NDI based on MDNS? I don't know. I mean, the plugins are here for Linux, so that's all I know. So, all right, let's go back to this, and I'm going to disable the NDI output on the laptop, so maybe it'll be slightly better performance. I don't know. Okay, there's that. There we are. Alrighty. What was I doing? Oh yeah. Let's change that, because that sounds kind of awesome. Whoa, what did I do? Is there a button? Oh yeah, the number key zoom. And okay, now it'll apparently know their diff pairs, so that's really cool. All right. Don't need that. I think the RTMP thing is even more behind now. Oh, it's way behind. All right, I will go hide it and show it. That'll reset it. It is very, very behind. Very behind. Hide. Hello. Show should reconnect. Let's go ahead, just for giggles. Do that. And okay. I will Ghost doing KiCad now, yeah. Pan the schematic. It's not ideal, but all right. Okay, yeah, there's not a lot I can do about that, unfortunately. I really tried with the NDI stuff, and because I'm doing multi-monitor, it's not even remotely possible to do display capture here. It would take a lot of work. Oh, I'd be okay with it becoming self-aware. It can do the schematic for me. That would be cool. Okay, that was a lot of nonsense stuff. We haven't actually laid out a single trace yet, so let's get back to work and do that. So, this is done. We have that labeled. We can ignore that for now. Okay, so back to this. All right. So I was working on, last night I did the data lines going up through everything. They do connect to the UART up there, and this one trace I can't visually confirm that goes to there, but through context of everything else, I'm pretty sure it does. I thought, though, that I'd actually traced these out, or is there something skipping? Let's see, 1, 2, 5, 6, 7, 8, so pin 3, where does that go? I kind of want to work on that, so let's do this. Green, okay. Let's figure out where that pin goes. So 3, oh, hold on, go to that. Oh, you know what? I kind of wanted to look this up because I was annoyed I couldn't do it yesterday. Is there a way of locking layers in GIMP? GIMP, lock, layer. GIMP, you can either protect layer or press Control layer to bring the layers palette to the forefront. Click the layer you want to lock on the list of the layers palette. What? Lock alpha channel, lock position and size, lock pixels. So can I do that and that? Does that make it? Okay. Is that how that works? So now if I'm on this and I try and draw, I can't. Aha! Okay. Oh my gosh, I feel like such an idiot. I thought you could not lock layers. Well, there we go. That's really helpful because yesterday I screwed up and drew 3 of the data lines on the red layer, and I had to redo the red layer. Okay, let's follow this. Okay, so that goes from pin 3, boom, to 711, which is, where is that? Yeah, 711's way down there. Okay, to pin That is 8. Boom, boom, boom. Okay. So, all right. Pin 4 is probably power, but we'll ignore that one for now. Pin 5, that's just a test point. I don't like that. Well, actually, can we determine from context where that one's going? Not really. Wow, that one goes all over. Oh, that one's going to be super hard. Blah. Go to purple so I can illustrate this without marking it as done. All right. Let's say we want to do this pin right here. So we're going to go down to there, go across, go down, go... Oh, does that connect to there? Oh, maybe it's not too bad. Okay, I thought it continued on. Or wait, was it this one? Oh, where does that go? Hold on here. Okay, so if I'm seeing this right, this pin goes here to here to here to here to here to here to there to there, there, all the way to there, 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 there, and then somewhere in here it connects on the top side, and we don't know where. So that pin goes all the way around the whole circuit board. Oh, that one's gonna be gross. That's one we'll figure out once we've done more pins on that chip down there and we have a better idea of which ones are left. All right. How many pins are left on this chip? 1, 2, 3, 4. All right, let's just start there. Let's do this one. All right. So you're looking through some posts, multicast traffic for detection doesn't work reliably on Debian-based distros. Suggestion is to enable main output on client, give it a name, client. Do the same on server, give it a name, server, and then manually add. So GPin, what I did is I don't know why you'd enable the output on the server because I don't need them to go back and forth, but I did manually name the laptop, and then manually name, or that was the output. I named the output on the laptop, and then put the text laptop in as the source for NDI over there, and it still didn't work. So I did try, but it didn't work out. Okay, 7101. So this thing, all right. Now, if you get fancy here, you can right-click Properties and then find, there is a data sheet. Cool. Let's open that. So 2.4, is that even close to correct? It actually is. We linked a different data sheet here, though. So for 7101, we went for this, which is Philips data sheet, which we could honestly probably link to the one that's actually hosted by Philips, but this is fine for now. So, oh, thanks archive.org for your difficult to pan web browser. Okay. So that's this chip. So we turn it sideways and look at this. I'm going to bring this over here. So bottom is ground, all right? So this pin almost certainly connects from here to there, like pretty much guaranteed. So we're just gonna go ahead and connect ground over here. All right. See, Googler's drive is old. Came across 13 gigabyte hard drive attached to P300. Lilo to start. Debian? Oh, interesting. Okay. I don't know where those... Well, that's power, but that doesn't go... That's a tie up. Okay. This... Where does that go? Could go to that, but that doesn't make sense. Yeah, I can, Helen Croft, for sure. Connect all the power without question. Yeah, I'm just trying to, like, visualize how they're connected here, though. So, like, VCC up there definitely just connects right there. So I can grab this and put it... Can you just copy paste, please, KiCad? Select, copy, paste. There we go. I didn't need the wire, but sure, why not? Okay. So yeah, that would be that, which leaves these two pins. This one goes up and has an adventure somewhere that we'll figure out in a moment. It looks like it connects to pin 1 here, and that connects to 2 things. 100% auto router PCB. Yeah, you're saying this one is? Because it... I could see that. All the right angle traces on here make me think that it's definitely from the computer generated era. I don't like this one though. I don't know where that's going. It's definitely not going this way, that's for sure, which means the only thing it can connect to is that. And that's part of the 595 data bus, I think. Yeah. What is this green trace going to? Because there's one on the bottom, but then there's that. Find outer chips to connect to the data bus. That's this. That is exactly what this is. This is the first chip that gets the data pins. Let me hide the bottom pins. This is the data input chip. What pin is that? That's B. Hold on. Oh no, stupid thing. Hold on. Maybe we can infer this from context. Other chips like UART or shift register. Yeah, but well, that's what I'm saying. I have all those done. This is the full. Like here, if I go over here, so this is the chip that we're looking at in this, right? So that's the chip. It connects directly to the ISA data bus. And then I already have the green traces on here are the data bus going to all of the shift registers and then up to the UART itself. So that's kind of done already. So now what I'm looking at here is that there are There are two other lines from the data bus that are maybe not complete. So D6 and D7, and then there's B6 and B7. Data bus can't just be 6-bit. Yeah, but that's the thing is like, how is it connecting? So let's look at this one here. Let's run this. So boom, 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 boom. Actually, hold on here. Is that a scratch? That's probably a scratch. Should open the other one so we can look at that. So bottom side. Yeah, that's a scratch. Okay. So here, there, across. Yeah, that looks like that goes to pin 1 there, which is already, actually, hold on, pin 1. No, that doesn't make sense. What did I do wrong? Oh, that's how... Oh, I see. I'm looking at pin 1 on the shift register, not on there. How does one archive multi-layer PCB traces? Destroy boards. Yeah, that's pretty much it. That's the only way you can do it. Or X-ray. And then I think... I don't know if you can do, like, layer-focused X-ray. Maybe. Alright, I think that's how... that one gets there. So that explains that trace. Okay, so that one has been found. We got that figured out. Well, APJA, yeah, that's what he's saying, is to destroy the boards. You could do it with sandpaper. It would be really hard. They can do 3D X-ray? Yeah, that seems familiar. So you could potentially X-ray the board without destroying it. I have heard that there are services in China where you can send them a device with a PCB, and then they will do the destructive process for you and send you back Gerbers. So you can have a service do that somewhere. I know someone who's done that with some medium rarity vintage PCBs. So it should be possible. Okay, so that was pin 1. Pin 15. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's part of the data bus. Okay. So from context, we can figure out that goes there, but from here, we can't be 100% sure, but it's probably going from here to something like that. And then we can go back to this, to here. So we can probably say that this connects to pin 15 for the last pin of the data bus. Yeah, that makes sense. Okay. This pretty obviously goes boop, doo, 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 doo. Why does that go there, though? That looks like that splits off. Alright, interesting. Let's make that a little more accurate, too. So that's... Oh my gosh. That one... Wonder if you can get used medical equipment cheap? Probably. I don't really think that medical equipment is that tightly regulated. What are you gonna do? Open an illegal hospital? That sounds a little self-defeating. Like, if you're good at it, it won't matter. Like, a lot of SVHS players you can get are retired medical equipment. Alright, there's that one. And now let's just go ahead and connect this to that. That'll be pin 8. So 1, 2, 3, 4, 5, 6, 7, 8. Ah, okay. So we're gonna have to make a context guess here. So from here to there, all the way down to there. Then it disappears. I'm gonna do that. Disappears there. So it's probably going from here to right there. I'm gonna yoink that one again. And also, I should put that down here. That one's a bit speculative, but I feel like that's probably it. All right, that's, that chip is done. We can, that one's golden. We've done all pads on that one, so I kind of want to make like a, ooh, man, I don't know if I can fit another layer without having the whole thing, like, lose its mind, so maybe we don't do that. I want to mark that somehow as, like, done. Oh, that's gonna be really hard. You know what, let's just try this. If I add a layer, how big is it gonna be? Add layer, complete, save. It's now, oh, that one was only 52 megs? Oh, we're so good. We're super good. Okay. Semi-transparent color overlay. Yeah, that's what I wanted to do, Helencroft. That's why it was going to be complicated if I tried to do it on my drafting layer as well. So I'm going to do this. And now I don't even have to change the opacity setting of, like, the fill. I can just do that. Boom. That chip done. All right. Let's see. I've just evolved in Madness networking 2 of my C64s using modified CB radio in the cassette port. That's kind of cool. All right, there we go. So that chip is golden. We can call that one done. This one, I think we could knock that one out. Okay, so I have a trace going there for some reason. Oh, that's dir. What is dir? Dir. Direction control. Okay, I don't know what that is. It's going to 1, 2, 3, 4. Oh wait, yeah, 1, 2, 3, 4. Fourth from the bottom. That's an address line. I don't know. All right, it's not ground. But that one, we don't know where it goes. Maybe it's no connect or connected to, I think that one was ground. Yeah, so maybe it's just going there. That's complicated. Let's see. Transceiver can move data both ways. DIR selects which way. All right. Is no connect on, that's a 244 actually. That one's different. Let's go back. 244. What's top pin on that? That's output enable. Okay, so that one, actually that should be tied high because it's active low. Oh wait, active low should be tied to ground. So that one's probably just going to here then. If it's active low, yeah, you'd tie it to ground. So, okay. Grab this, copy. Sure. Boom. Okay. It is, yeah, bottom side is ground. Okay, so that one we're pretty good. I can also come over here, not wire, copy, paste, connect 10 to ground. Boom, boom, okay. So we have, which pins are left here? We have this one that's probably going to whatever that trace is, and then this one that's probably going to whatever that trace is, but we'll, what did I just do? Okay. I will yellow mark those, because they're not confirmed. Alright, what's a key for the eyedropper tool? Why is it O? And pencil is N. That makes total sense. O-N. Sure. Alright, so going to there. Yeah, that lines up perfectly to there. Alright. And then O. That goes to there. Obviously that to there. So that probably, whoa, that was a different color. No. Okay. So that's pin 9. Here, whatever that is, connecting to pin, what is that? 1, 2, 3, 4, 5. 9 to 5. 5 over there does not have something connected yet. Okay. And that one goes off a whole on an adventure. Jeez, okay. Let's continue that one, I guess. I don't like this one. That one probably continues. Also, let me mark that as probably. Well, actually, I don't have context. I'm going to mark that as not sure. It makes sense, but I don't have context to back it up. Okay, so that's 708 pin 1, 2, 3, 4, 5. Okay. So that's quite the run. 11, 12, 13, 14. All right, hold on, let me just mark that. 14. Boom. To 708. Was that pin 6? 1, 2, 3, 4, 5. Going up to this. I am marking that as not sure. Looks like it makes sense, so, man. Okay, down to this one. That one, that splits off multiple places. I don't like that. All right, let's figure out one. Okay, so pin 12. Both OE pins of the 244 need to be low for it to work. One moment. Okay, so the 244. So we have. So you're saying pin 19 here. 19, 244. Oh, that is ground. Oh, I'm an idiot. Seriously? Good catch. Yeah, I had that backwards. That one's ground. So that's 11, 12, 13, 14, 15. Yeah, so that there wraps around from the ground through that and down there. So that makes sense. Okay, so back to 12. And it's 206. Bring those into view there. Okay, so from here, boom, boom. Okay, so 1, 2, 3, 4, 5. Okay, so 12 to 5. But also, it goes here to there, and then unsure under. I'm pretty confident about that one though. There. Oh, that splits, or is that another scratch? Let's check. What's that? That looks like a scratch. Okay, that's the same one as before. Okay, so it continues way on up Man, that one goes on a journey. To pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of that. Okay. Is way over there, right enable. Man, that's a route. Let me backtrack that, just double check. Nice, still working on the schematic for this here. Yeah, it's gonna take a while. There's a lot going on here. I don't really know how much percentage-wise we have done. It feels like 30% maybe? I don't know. Right enable to read pin. Is that a read or is that an output? I don't know what that is. 244, okay. 12, Y3Y. Y3Y. 1 Y3Y is bus output. So that's an output to write enable. So yeah, that was boom, 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 boom. Up. Yeah, that's pin 12 on the UART side. Yeah, the UART is write enable. That's where it's going. Oh, wait, I mixed it up. Hold on. There. I got it. Man, it's so easy to make a really minor mistake. Good catch. All right, I think that one's it. I'm just gonna leave that one. I don't think there's any other possible way that could go for that yellow one. So I'm gonna not bother marking that. Okay. And that's power. I'll just go to there. So we need 3 and 5. 3, 5 I have absolutely no idea. 5 is an output. That's probably just no connect. Let's go over to here. Bottom side, nothing. Oh, wait, is that a connection? That is really hard to tell. No, I don't think it is. I think it's the reflection of the flux residue left over, because they all have something right there. When I've seen pins, traces that directly connected, it's kind of obvious. Where there was one somewhere up in here. Where was it? That channel's not used. That's what it's looking like. There it is. That's one. That one's pretty obviously connected. Like the solder mask is going off into it. So that one's connected. And from the context of the schematic, that's the bus. It goes up from chip to chip to chip. But yeah, that's just the flux residue. Okay, so we're going with 5 here, no connect. So all right, 5 is no connect, but 3 has some stuff going on. Let's see. Unused input is grounded. That's an output Y2Y1. 2Y is a bus output. 2Y1. So would that, I feel like an output wouldn't be grounded, but we really have no way to know. 2Y1 goes to the UART. With pin, this is pin 5. 1, 2, 3, 4, 5. It's this one. This is the 244. I'm just going to do pin 3 really quick and come back to that because I think pin 3 is going to be a cakewalk here. So it just goes right up to the 40. Can't see the schematic because chat is over it. So, oh, sorry. Yeah, so pin 5 here, that's the one we're looking at. It is 2Y1. Yes, pin 3 goes to the UART. It looks like pin 3 so far just goes here to this chip to 706. And that's pin, how many is that? 1, 2, 3, 4, 5, 6, 7, yeah, 8, 9, 10. So 3 goes to 10. Up here. I need to do that tray still. I feel pin 7 also needs to go to the UART. 1, 2, 3, 4, 5, 6. We were looking at the same thing there. That one might. There's clearly something else going on there. But are we? So pin 3, I don't think goes to the UART. It looks like it goes to whatever that is. Let me double check over here. Pin 3 goes to the test point. And then that's flux. That's not a contact. It goes straight into that. And then there is nothing on the other side, I think. I don't think that's a via. I got pin 3 messed up because of chat. Okay, okay, no problem. Let me see if I can make it so that it can't go under chat here. Let me just move it over a little more. I'll obstruct the image there. Ooh, you know what I might be able to do? One moment. Oh, I already have GIMP open. It's right here. File, new. Oh, I put it on the wrong one. Whoops. There we go. Cut out some of the corner that's not really needed and moved it over, so that might help a bit. Now I can move this back over, kind of. Okay. OBSception. Yeah, I got a bunch of OBS going on here. But pin 5 over here really looks like it's not connected to anything, so I'm going to mark that as no connect. Add NC. No connect. All right, you know what? I think there's still some down here. Yeah. Copy, paste, copy. Not sure. Don't know how to verify. There's nowhere to test to when you think it's not connected. Could be ground. That's a thing. Could potentially check that one to ground. That's no problem, David. Okay, so we're going back to... That's... So I want to do pin 20, 19, 18 here. 5 is a buffered ground. So 5Y, 2Y, 1 is bus output. So you're saying that would be grounded? I don't know. I'm probably missing the sarcasm if you're doing that. Ground is in, ground out. Ground in is ground out. Okay. Oh, wait. So you're saying logically it probably is. 2Y1, 2A1. Ah! Okay. I got it. Okay, that makes sense. Okay, 2A1 here is grounded. All right. So it would be either or no, it really doesn't matter whether or not it's connected to ground. If it is, whatever. Okay. So that's just like a whole section of the chip that they're just not using. Got it. So I'm gonna leave it as no connect for right now. Yeah, they connected an unused input to ground. Yeah. Because 15, 1, 2, 3, 4, 5 here wraps over to pin 19, which is one of the output enables that's active low, I guess, to ground. So yeah, that checks out. Okay. Now I'm going to upgrade that from not sure to probably with context. But that's like long. So maybe new label. Probably with context. Boom. Okay. Now I wanted to do pin 18. Okay, let's do pin 18. Pencil. And boom. All right. That goes there. Goes way off. Down there. To there. To there. To there. To there. Over to here. Uh-oh. It's getting real close to the scary UART mystery pins. Oh, no. That one does not line up to any vias. Uh-oh. Huh. Alright. In most cases, especially with CMOS, you would want to connect unused pins to something at least. Well, yeah, the input is connected to ground. It's the output that I'm leaving not connected. So that's what, that's how I have that set up. But I have literally no clue where that could be going. Or actually, do I? It may... Oh no, I don't like this. I don't like this at all. Where does it come from? That's pin 18 on the 244. That is an output, Y10. But what I was going to say is that it could theoretically come all the way down to here. Because every other pin, so A0 of the UART. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why A0? What is A0 on the UART? I don't see an A0 on the UART part. Actually, I don't see any addressing on the UART. It might be connected to CD. Yeah, CD. Are you okay, so I'm feeling theoretically it could be CD because I think we have every other pin up to that one done already other than 11. Well, okay, so let's go through each pin here. 1, it's connected there. 2, probably connected there. 3 goes off. Yeah, 4 has a trace on the backside. 5 is connected on the backside. 6 goes backside trace. 7 has marked trace. 8 has a probably trace. I think that one was from context. Yes, it is. 9 trace on the back. 10 marked trace. 11 trace on the back. 12 no trace. 13 don't has we haven't figured it out yet, but trace on the top, and then that one is probably ground. So 12, 13, 14. Ooh, that's not a ground. Oh, David, thank you for the gifted sub. I missed that. Okay, so it could be either one of those. It could be 12 or what was that one I said? 14? Is that a 28 pin? Looks like it. Because we don't have a pin, a trace for that one, and I don't really see how we're going to figure out a trace for that one. Don't think 14, that is an output. That, RX RDY. Okay, that would make sense. Okay. All right. So we'll say 12 to, oh man, this was a really complicated trace. Great, where'd that go? I'm gonna have to reverse it here. Holy moly, that thing goes on an adventure. That was pin 18. Okay, 12, boom. Goes to pin 18. And then I'm going with probably with context. Actually, I'm going to mark that as not sure. In my mind, the not sures are ones that I want them to check before I place the board order, and probably from context as ones that I'm not going to have them check. I would like them to check that one. I feel like that's a pretty... I mean, it makes sense, but it's not like a 99% confidence level. So... But we don't know where that output goes unless it's just not needed. Actually, RxRDY, that would be like CTR or CTR, clear to read or something. Test the circuit on an ISA proto board first. I super duper don't want to hand wire this. There are a lot of traces here. The way I figure this, all right, is that I'm going to be making a schematic for this no matter what. And PCBs are cheap. I would rather just buy PCBs and solder sockets onto there and just plug in all the chips on a Rev 1 rather than proto board it, because so I think I'm gonna do that. What's the dono go to wire wrap this? It would be a lot. It would be a lot. It would, oh man. Ugh. Because I have a high resistance to that for multiple reasons. It's not just that it's like that would be hard and it would take a long time. It would also be that this is my first reverse engineering board. Cannot be used. Yeah, that's what kind of what I'm thinking, Hellencroft, because there isn't, like, what was the pin out there? All right, response plus minus, command plus minus. I don't know what all that means. Data clock. Yeah, it doesn't seem like, well, attention could potentially be something like that. Yeah, that's the way to do it. Print up the board, cut and jumper if there are mistakes. That's what yeah, that's how I'm feeling, J-Metal, because PCBs are so cheap now. You know what's funny is no matter what, I'm still going to leave my eBay search running for one of these cards, and I'll probably eventually buy one, and it'll be hilarious because I won't be able to resist it, and I will have to take off all the chips so I can see exactly what the traces are. So someday I'll probably have a real answer to these, more than just, yeah, it actually connected or no, it didn't, when I get them to confirm a couple of things for me. But I don't know how long that's going to be. It could be, you know, next month one shows up, or it could be a decade from now. Because it's a kind of rare card, I think. See, UART ready pins are buffer stuff for interrupts DMA. Won't go to the CD drive if they are used at all. Okay, that makes sense. That was pin 14. Oh, it's marked on silkscreen. I could have been looking at that. Pin 14, maybe no connect, not sure. I'm gonna mark that right now because I feel like we're not gonna get a more concise answer. Oh, I just realized I forgot to Twitter this stream. Oh well, it doesn't matter. I was very late to the party on this one. Let's see, 15 might connect to something. Oh, that's weird. Now I'm not really sure what's going on there. 14 and 15 not connect 90%. Well, I'm looking at 15. There's a bunch of stuff going on around it. Like, it could be that trace there, maybe. And then there's this, which it would make sense for this to also go here. 16 also not used. 16 side net. 15, 16. Yeah, that tracks for how stuff looks. I'll go ahead and do that one right now. $18, 15, 16, 17, 18. Yeah. That one is, okay, let's do an 18. Oh, from context, it's looking like 15 is probably not used, so I will mark that one too. Because every part of that block for the logic, yeah, all those 4 pins not used. That somewhat makes sense. Just because all of them look like they're not connected, so maybe none of them are. I'm gonna mark that whole section probably from context. Okay. Anyway, I want to get back to that one chip up here. I think we have this one done now. So, oh no, we didn't do that trace. That's right. Why did we not do that one? 10, 9, 8, 7. Okay, so this one has a real big adventure to go on, it looks like. So there. Okay, so that's 1, 2, 3, 4 on 706. So goes down to 7, but then 7 goes all the way to 13 of the UART. All right, let's track that down. Oh no, it splits again. 1, 2. All right, let's figure this out. Boom. Are you looking at the traces on the images directly, or are you just doing this from what the use case of the chips are? That definitely goes to pin 13, 100%. IORT already makes 100% in a logic sense, or sense in a logic sense. All right. So you know the chips then. That's your secret. I am very unfamiliar with 74 series logic on average, on the whole. I've used shift registers of 595s. I've worked with those, so I have a rough idea of how those work, but that's it. Okay, there was another split for 7. Where was it? Here. Okay, so this also, let me just confirm that. So pin 10, 9, 8, 7 goes boom, boom, boom. Yeah, so right there it goes into the via and most definitely splits off into 2 directions. My gosh, they very clearly did not have a human route that mess right there. Just look at that. That is gross. No human would have done that. Anyway, that's all right. Go here. Boom. Or middle. I'm gonna just keep dropping traces every now and then. Make sure I stay on the right one. To there. Okay, so we're going to pin 1, 2, 3, 4 on 708. So this was this to pin 4. So 244 is just a buffer from left to right. Okay, so if IO read goes in on left, it comes out on right. And UART has read input. Okay. Oh, all right. That kind of makes sense. Okay. Okay, do we get a call this chip 100% done? That pin, ground. That pin, we've got everything. That one goes off, boom, done. That one goes directly to the address line. Okay. I'm not worrying about test points right now. I will do all those after the fact because they're pretty obvious. And I'll just sprinkle them around. Okay, that one, no connect. That one goes down. This one has a party that it goes and does. That one goes there. Wait, did they really have this one go to the underside of the board just so they could stick a test point there? Wow. Okay, this one has the context sensitive. That one's ground. That one, yep. That one, done. That one, yep. That one, okay, yep. Yeah. All right. Okay, so if I'm understanding the chip more right here, test points on the bottom for bed of nails testing. Ooh, I had not considered that. That's cool. So, okay, so if I'm understanding this correctly, that goes in on the left and out on the right. So there is, I'm just gonna do one line here, it's kind of garbage. Data coming into this address line, and then it comes over here, and then comes right back out to that address line? Is that what I'm seeing? It's a little hard to see on there. So if I hide the drafting notes, yeah, in on that side, out on that side, and then right back in. 244 is stupid because gates are all flipped physically. Okay, so that would be pin 4 and pin 20, 19, 18, 17. 4 and 17. 17, 3 and 4. Okay, those are two inputs. Oh, it is stupid. Okay. Yep, it's stupid. Yeah. It is stupid. For the function diagram, that makes sense now. All right. Ugh, gross. But that one looks done, so I'm going to mark that one as complete. So, eyedropper. Oh, that sucks that the eyedropper doesn't just get the actual color. All right, rectangle. Boom. Fill. Oh, wrong. Done. 2 chips down. Some complicated chips, too. All right. That's not even close to done, but I kind of don't want to deal with that. Let's go with that one. That one looks like it's going to be really, really easy. I like this one. This one's clearly just for addressing and whatever that one trace there goes and does. Still not too bad. All right, let's do that thing. Okay, so pin, actually let me bring up the schematic or the data sheet. This is 704, so much stuff. 704, okay. That. Okay, so A0, VCC, and ground. Okay, so we can definitely say for this, ground and VCC, well, that's already done, but let's just go ahead and mark them. And on drafting, boom, boom. Wait, what? Oh, rectangle. Boom, boom, okay, boom, boom. All right, those are done. 7X541 is a 74244 with not stupid pin layout. That's funny. I wonder what the reason for the stupid pin layout is. If there was like the way the die was designed initially, it just made sense to have it be like that. That's kind of weird. Okay, so that whole side. Wait, what is Y5? So it may just be not used. Ah. Archive.org really has the worst PDF viewer. .244 from 4-bit error to have bidirectional buffer. Interesting. Oh, okay, I think I see what you mean. So it's still, it could be used as an 8-way buffer or 8-bit buffer, but it's meant to have like 2 buffers going, okay, both directions. All right. I'm just kind of looking at this to get a grasp of it, because there's some really obvious stuff going on. But I'm just trying to figure out like how it works. So I'm guessing these 4 these are the 4 inputs. These are almost the 4 outputs, except for that one right there. Actually, you know what? White would be a lot better to use here. 4 inputs, 4 sort of outputs. Why is that one skipped? What is E1? All right, it's a weird chip. I'm just gonna give up. I don't understand it. It seems like it's like a rows and columns encoder to a bus output. That's my interpretation, which is probably wrong. So I'm just gonna not worry about it, and I'm gonna dumb monkey do traces now. Because that part I get. Okay. What is that side connected to? Well, let's worry about this. Pin, what is this? 10, 8, 16. 1, 2, 3, 4, 5, 6, 7, 8, 16 pin. Okay, so pin. Ah! One output is enabled according to the inputs. Okay. I think the way that I'm looking at this right now, I'm just not going to understand it. So I appreciate the attempting to explain it. It's just I'm not there. I'm not in the right mindset for that at the moment. Okay, so 15 goes to... Wait, does it actually go to that? Okay, yeah, pretty obviously. Wish I knew what the rest of those were going to, though. I get what the 3 to 8, that makes sense, but then I see 4 inputs over here and then I get confused. So yeah, I get what it's doing. Hold on, let me do 15. Boom. But there are 3 inputs. Yeah, that, see, 1 output enabled. It's more like those are the outputs to me. There's 4 connected to the jumper block. Yeah, sorry, I'm probably just not gonna get it from what I'm seeing here. The other inputs are chip enabled. See, then that gets extra confusing because it's like it has 3 inputs, except it also has 6 inputs. A CD controller, AK Sonoa. First off, hello, since the first time chatting. This is literally just the card that you plug into a computer to use a CD drive. So this is a very old CD drive from 1985. This is the connector that you plug the CD drive into, and it sits in a box outside of the computer. I don't have this card, but I do have the CD drive that goes with it, and I'm trying to clone the card, recreate this card from these pictures that I was sent. That way I can use my CD drive. So that's what I'm trying to do. All right, so 14 goes to this one. That goes to that one, and that goes to that one. All right, and we can wait. No, that goes to there. Delete, and that goes to there. Delete, because we are skipping 13 for some reason. Would imagine its drive itself would be cheaper than the card? No. Well, I mean, I think the card is less interesting, and people don't know what it is. So when the card gets listed, people are just going to say, oh, it's a CM-153. And then it'll be on to the people who know what a CM-153 is to try and buy it. The CD drive, you see Philips CM100 and it's a CD drive. You're going to look up what it is before you throw it on eBay, and then you're going to list world's first CD drive when you list it on eBay. No one's going to look like attach, you know, first CD controller to the eBay listing. They use the 3 enable input pins as a hacky way to get more address pins. Yeah, see, that's kind of what I was thinking. Looking at this, the hacky ways make this a really bad example schematic to learn how this thing works. But then I'm looking at outputs here. That's the other thing. Is this just going the opposite way? Is this a binary or a decimal to binary converter? The opposite? Or does it go both directions? because these are on the 8-bit side, not the 3-bit side, one way. So then I have no idea what this is doing at all. Because I'm right here, right? These, on this side, these are the outputs. And that's what I'm connecting over here. These are the outputs. Read your comment, J-Metal. Okay. So the jumper block connects to the outputs. Each output corresponds to an input address. So you are selecting which address you want to send to the chip enable of the next IC. Nope, I'm not going to get it. Just forget about it. I'm not going to get it. Just don't worry about it. It doesn't matter. I give up. All right, this is pin 1, 2, 3, 4, 5, 6. I don't like that. Probably that. So 4, 6. So pin 6 here, all right, is going to pin, is that 8? That's 7 pin, yeah, so 8 on 706. I understand the basic premise of what you're saying the chip does. I don't understand the application. That's it. That's what the problem is. So, all right. Is that... So this one here... pin, what is that, 12, 13? Does not appear to go anywhere. And neither does pin... 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 is, yeah, so 9, also 7. What? Oh yeah, 7. How old is this card? It would be designed for release in 1985, because that's when it is. 4 not used pins is normal for the setup of this chip. Okay, so that would be the 4 not used pins right there. Okay. We're gonna go ahead and mark those as not connected. So chip done, yeah. Paste, paste, paste. No, insert? No. I'm gonna undo because I don't know what that did somewhere. That's right, it only does creations, not copies. What is the point of the NC pins? Just cheaper to leave them there. So the no connect pins, it would be they need this particular kind of chip's functionality, but they don't need all of its capability. So they need what it can do, but they don't need how much of it that it can do. So they'll just leave those unused. We have another example of that over here. This is a serial chip, and the serial chip has some more like handshaky, like, okay, we're ready to communicate type stuff going on in this area. And the way that the CD drive connects to it, it doesn't look like it needs any of that. So those are all not connected either. So I would imagine BBS admins loved these drives. I don't know. It's kind of really early for that. I don't think it would have been too many use cases like that. So, but maybe. I don't know. And hello, BeatStack. All right, yes, we can mark that chip done. Let's go ahead and do that. Rectangle. Boom. Oh, wait, wrong layer. Boom. Chip done. That's one of the best feelings here. All right, I would like to mark this as done, but I'm really not sure what's going on here. Because I'm seeing these 3 traces all right there, and they're gonna go places. I don't like that. So we have this pin that doesn't go anywhere, so it's possible. I'm gonna yellow. I'm gonna yellow trace for a little bit here, just for giggles. So it's possible this trace goes. Wait. It's possible this trace goes to here. So that's, oh, they run the ground around and end ground right there. So there is no ground. This one, there's nothing. Oh, cool. The silk screen on the address jumper can confirm the pinout of the chip. Maybe? I don't know what's going on that side at all. I'm wondering if maybe this trace comes through all of them. Would that make sense? Because I don't know. It makes sense for that one trace to go through all of them. All right, I'll do that for now. You select one jumper position, yeah. But I would have thought that would have been like tied to ground or something, but it isn't. It seems to go off to whatever's up here for some reason. So this one, well, let's say this, all right? Is there, yeah, this chip, this pin right there doesn't seem to go anywhere. So this keeps on going up somewhere. It could connect all the way up here. Assuming that's a power chip pin. That one I'm super duper not sure about. Okay, what is pin 1? Pin 1 is an input. These AND gates? I think they are. Quad OR. Oh, they're OR gates, okay. Sorry I'm being so quiet here. I'm just kind of trying to figure out how this is supposed to work. This stupid chip here is driving me insane. These are all outputs. Then if any of, and if that's an input on the 32, the 7432 here, so pin 1, it would make sense if that's connected, but I don't know. It has to be an input, so it's pin 1 goes to pin 3. 3 goes off to whatever that is, the 4024. So if it's pin 1 or pin 2 goes to pin something. 1, 2, 3, 4, 5, 6, 7. So 14, 13. Oh. There's a via right there. Yeah, Helen Croft, I just realized that. Okay, so with that in mind, I am guessing that it is that and that, because they wouldn't put a test point on there if it wasn't connected to anything. So that one probably has to be connected to something, unless it's not an input. That's 14, 13, 12, 11. 11 is an output, so that could make that, what does that go to? Something in there. Oh, God, that one looks awful, too. Gross. How many ICs? I mean, there's not that many. It's just that they're big ICs, so they cover a lot of traces. Oh, it's actually a little easier to see on this, although actually no it isn't, because they're all the stupid individual units. Yellow lines look good. Do you think that makes sense? So then pin 14, 13, 12, 11, 10 is just not connected. In that case, pin 9 would probably not be connected, but it is. And then pin 8, unless it just you want to use that as a buffer, I guess. It is a fairly basic card. It's just there's a lot of jelly bean logic on here. 10 needs to be connected somewhere. Yeah, so it'd be ground most likely then, because it would make sense for it to just go there. Oh, no, that's high. No, then that would always be out. So that doesn't make sense, because that's power. Ground is on the bottom. 10 could be connected to 11. That? Oh, I don't like that. I want to look at the chip plane. Oh, AK, I can see, Sonoa, I can see the back traces. The thing is that that doesn't show me everything, because there's traces under the chips. That's the problem. That's what makes it really complicated. So like this is a via, so that means that there is a trace that connects to it on the other side. And on the other side, we have 3 traces going in. So we don't know which one actually connects to there. The only thing that we can go over is that they can't cross. So we're using that to try and deduce based on which other pins have traces or not. Because there's a lot of traces that are actually connected on the back side. We can rule out lots of pins as to whether or not they could be connected. But like that one, maybe? Nope, that one's connected there. So yeah, it's just, Ooh. We can't very easily see which traces are going into which pins on this side. I feel like I've been trying to figure them out. Those individual ones, not that long after you got here, but the whole card I've been working on since yesterday. I'm gonna look through the other pictures. I don't think any of them are really gonna help for that. Oh, that's right. Gwenview's decided not to. Wait, no, it did load. Okay. So yeah, I can't make anything out from there. Pin 10 to VCC don't make sense. Yeah, it would be useless. I agree. But what I'm seeing here is that there are some highlights there, almost like it could be connected. Because like we can see up here, that's just a loose trace. So that one clearly must be connecting that pin and that pin. And then there's little bits that are highlighting there and there. So that one could possibly be touching those pins. It doesn't necessarily make sense, but yeah, the chips are very opaque, OLN. Really, the only way to do this completely, no, that trace goes past all of them, yeah, but I'm just saying there is shadow. It's kind of like the one over here, the socket trace, that one. We can't really easily see that here. It's possible the scans, actually. So there's photos and then there's scans. So maybe the scan. Oh, that shows it. The scan is really low resolution, but it's much easier to see. Okay, so yeah, definitely. Ooh, that's... Nah, probably doesn't touch. There's a good alternative view, though, for that particular problem. I might even be able to see the socket. Not really. Yeah, we don't have the physical card. Yeah. That is the problem. So I'm traced between 10 and 11. Ooh, hello. That does appear to be a trace there. Very good catch. Yeah. Yeah. The CD-100, is that on eBay? Is there one on eBay right now? I'm curious. Hello, Brian. We are doing pretty good. Yeah, there is one on there. Why a new laser? That's weird. Huh. Well, there is one. What do you know? Yeah, that's basically the same drive as what my CD-ROM drive is. Yeah, Brian, we're doing good. So I think we can go ahead and say 10 and 11 are connected on whatever that chip was, 707. Where is it? Up, okay. Up. 10 and bam, that. Okay, let's go back to here. And yeah, so 14, 13, 12, 11, 10. Okay, so we visually confirmed that with the other one, so I'm gonna mark that as like an actual one. Yeah, it's going good, Brian. I'm just kind of beating my wall, or head against the wall, trying to reverse engineer this board. Going a little crazy. All right, I think that connects all the pins on that chip. So that kind of makes me a little more confident we might have this right. I'm just gonna take a moment to sit and stare at it, because, yeah. We have this chip in the bag now. I'm feeling better about it. The one thing that was bugging me here. Okay, so pin 1 and pin 2. Pin 2 goes to something, whatever. Okay, sure, why not? What's the name of the card? This is a Philips CM-153. Third yellow is crossing power. Well, that is actually true. Yeah. That one doesn't work. We can't do that one. Very good catch there, Yepnik. There are not more vias, it's just that one. That's it. And yeah, it's definitely VCC up there, so we can't just pretend that. So yeah, I'll bring up out the purple here. This blocks everything, probably. Which is a real shame, actually, because, I mean, it's just right there. Oh, we can see it. Yeah, that's it, right there. It goes 100% all the way through. So we can guarantee there ain't squat getting past that. So what is that test point for? How does something get there? Because 10 is an input. Yeah, BS chap, they are all like that. Where's the green bit on the left going to? What do you mean? That one right there? Between 5 and 6. 1, 2, 3, 4, 5, 6. Okay, so that one, that goes to a trace that goes underneath 7105, and then I think goes down to whatever one we figured it out as one of the ones that we marked as complete already. All the way down to 245. That goes to the 245. Inputs 11 to 10. 11 inputs to 10. Okay. So 9, 11 gets it from 12 and 13. Okay, so then where does that trace go? Yeah, we definitely, that one's solid. We 100% know that. That's why I marked that one green. I'm gonna go ahead and delete this, because that's not possible. Same thing. You don't... No, I need the yellow, because there's a trace. There's a trace going somewhere. It's. I don't think it's that. If that's what you're saying, I don't think it is. Because that one that goes through to, or should technically actually, I think here, be a green line. I think I just kind of overdrew it. I think this was already determined. That is, oh man, I hate this. That was the 245. No. Oh my gosh, what is that? Hold on. Okay, 245 pin 11, 12, 13, 14. 245, 14. Is there a way to just like select the entire net? Is that highlight wires and pins of a net? Yeah. Boom. Okay, so that's going to pin 5 on 706. Yeah, 706. So that's 708, not 706. What? Oh no, that is 708. I'm an idiot. Never mind. Okay, so yeah, that goes all the way over to there. Yeah, that input to pin 5 on 708 comes from the 244. It goes all the way. You're never going to see it on here because there's too much going on. But it is there. We know it's there. This is it on the schematic. That shows it a lot better. On 7107, okay, so this, pin 5, okay, 5, 1, 2, 3, 4, 5. 5 just goes down to 7105. So I could really easily mark that right here. So 707, 5 to 5, so 5, oh, I've already marked that to pin 4? Yeah, so that one's, oh, actually, oh, I did mark it, I'm an idiot. But 7105 is an input. E1. So that's a 32P. That's 32. 1, 2, 3, 4. Oh, you're talking about 5. Sorry. Wait, what? 5? 5 goes to 5. Well, okay, so I have this off by 1, I guess. But it's still an input. Yeah, 5 to 5 and 4 to 4. I don't know why I messed that up. But yeah, those output enables, those are inputs, aren't they? So that it is an input to an input? Yeah. So, oh, they do have, wait, there's one thing going there. Yeah, so their 5 goes off to something. Hold on. 5 goes to the output of 7106. But 4 goes to the output of 7106. 5 does nothing. It just sits there blowing raspberries. Yeah, pin 5 connects nowhere there on the top. Pin 5 doesn't connect anywhere unless it connects under there. Yeah, I was just getting there at the same time, Hellencroft. Okay. So bring back this. Eliminate all of that noise. Actually, hold on, I gotta go fix this. This does not connect there. This connects there. So this has to connect here. That's the only thing that makes sense. Then this one goes up to pin 1. And then this goes to that. Out of curiosity, what PC did you try the CM? My test bench. This is like right, I don't know if you actually can see that, but it's over there. So Pentium 200, actually the one that that Brian, who's in chat, gave me. All right, so all right, those are outputs. I guess that works, right? So goes through all of those. I'm marking this the not suriest of not sure. Just read something about even a 386 being too fast for the drive. Wait, for the CM-100? Because I don't have like a 286 system that I could put it in. So if a 386 is too fast, then there's no way I can use a CM206. Period. I think Hellencroft said though that they had the CM206 in a 386, but it might be that the CM100 doesn't work. Yeah, 5150 for the CD drive. Well, I mean, for this card, that's the thing, is that I was trying the CD drive with the wrong card. So, all right, we marked 5. That's done. Could just try the CM26 in an 8-bit slot. I don't know. I could potentially. Yeah, CM260 with a 386 and an internal drive. Yeah. I could potentially try throwing the 260 into an 8-bit slot, but it's got stuff on the back that looks critical. Like, here, just really quick, let me come over here. I want to hide that. So if we look at this, all right, the 16-bit portion there has a bunch of IRQ stuff, and I feel like we probably need that extra IRQ. So there's whatever those are down there, I don't know, but there's a bunch of stuff. 8-bit slot is the same 16-bit, just about 16-bit extension. So are you saying it's worth trying to put this in a 5150? Booting a 5150 is going to be a pain right now. See, you feel your brain is fried for writing bash script with arguments? Yeah. 16-bit card also uses 16-bit data pins, won't work in an 8-bit slot. Okay. Yeah, I had a very strong feeling that that one looked like it was using more pins than I could get away with on an 8-bit slot. Okay, so all right, so I think we've decided we've got this chip pretty well figured out. So let's go ahead and just finish that one. So the drive is CM100, yes. Okay, let's wrap this up. 2 and 13 are tied together. So 2, 13. Let me green line that. I'm just gonna go ahead and copy VCC and ground and put it on all of these stupid things over here. I keep missing. Seriously? Why is that one? I like how these pins are not uniform lengths. Okay, now I can, well, that's somewhat speculative, but we can upgrade that to yellow. Okay, go back to green. Pin 3 goes to, oh, far. Pin 1 on 715. So 3 goes on an adventure. Whee, way up here. That's not it. Okay. Is the screen capture very behind? Probably. I can just turn it off and on again to try and reset it. Yeah, it's because I have to do network screen capture right now because I'm doing the 2 monitors, so it is really, really far behind sometimes. There we are. So, schematic move. There we go. Now it's caught back up somewhat. Okay, so because you couldn't see what I was doing, I connected pin 1 here all the way down to pin 3 there. Okay. It started laying traces on the schematic when you got up. Yeah. That keeps happening. Okay, 4's connected, 5's connected, 6. Where's 6 go? All the way down to there. Boom, to pin 1 on 706. So 6 to 1. Boom. All right. Pin 8 is ground. We already, yeah, whatever. Pin 9 goes on a slight adventure there to pin 1, 2, 3, 4 on, what is that? 13. So that's pin 9 to 4. Onto 13. Where is, right? Okay, so yeah, pin 9 to 4. 1, 2, 3, 4. Yeah, that tracks. Okay. Why do I have this one green line? Oh, because I probably just deleted some stuff. Let me just fill that back in. And then double check 8. So 8, pin 4 goes to a whole bunch of nonsense. That's the one. Yeah, okay, that, sure, it's fine, whatever. Okay. And I just need to do pin 1. Connects to something really far away. It's looking like maybe it's snaking off to the UART. No. Oh, what? It goes to some kind of bus. Hold on. Is this a data bus I missed? Oh, I don't like this. All right. Okay, on the 595s, it connects to 1. 9, 10, 11. That was which pin? Should be pin 8, not pin 9? Wait, what? What? Wait, what now? Pin 8 to 4? Oh, okay, hold on. Let me finish this up and then I'll take a look at what you're saying. I think I know what you mean now. Okay, so 9, 10, 11. This was, I forget now, was this 1? That was pin 1. Okay, 1. Okay. Way up here, it was 1, 2, 3, 4, 5, 6, 7. Oh, yeah, that is 8. Good catch. Oh, excuse me. Okay, so we still need pin 9. All right. I don't like it when they go under resistors, but that's probably safe. So, okay. So, thank you, Yepnek. That was a very good catch. Uh-oh, that one feels very UART. Oh, but it isn't. Whew. I hate the UART. Okay. So let's go into whatever that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on 9. Okay, so 9 goes to 109, and it goes to pin 11. Okay, that's that chip done. Ugh. Why is that one not connected? Hold on. Oh, it isn't connected. Oh, okay. Well, fair enough. That explains why it's not connected, because it's not connected. Wait, what do you mean 12? What do you mean actual output? Oh, you mean over here. Yeah, that one's an actual output. Yeah, that makes sense. Yeah. Not inputs to inputs like that. That's super confusing. Yeah. Okay, 12. Let's figure out where this one scampers off to. Is that it? That doesn't feel right. Well, that definitely looks like it. Okay. So to whatever that is, but then we're not done. Just out of curiosity, you try loading... No, I did not try loading the CM-153 driver. It was my understanding that the drivers are very different, and that the only way it would work is the correct driver with the correct card, because the card kind of handles everything else. But I don't know. Yeah, there are probably permutations that I should have tried, but I just got kind of flustered. So that's 710. Okay, so 12 goes to 10. which is there, and I guess that's just an inverter. And pin 3. I don't like that. What? Pin 3 is an input. Oh, wait, that's right. I went somewhere else, too, though. Hold on. Oh, that was a mistake. I don't want to do that. Hold on here. I definitely need to pay more attention. Just grab. No. $12. 2, 3, but then we got to figure out where that's going. It seems there may be, yeah, there is a CM-155. Yes, I have heard of that. I have not seen one. That did not just snake off to a test point all the way over there. No, that yeah, I'm still at it, Majenko Tech. Okay, no, it does continue. All right, I was gonna be like, no way, no way. It's just invisible. Cool. Let's get rid of that for now. Okay, so that goes to that. 27, 26, 25, 24, 23. So it goes to 23. Let's highlight that one. 23 is RTS. Ready to send. Is that an output and is active low? Wonder how many other invisible traces are? Yeah, really. Request to send, okay. So that would definitely be an output then, okay. Times like these, I wish a molecular pattern replicator tech existed. Yeah, that would be handy. Okay, but that makes sense, and now that's a chip done. That one is done. Oh. Boom. Also, we can mark the jumper block as done. We have 5 chips out of what, did I hear that it was 20? But if you let all the pins that are easily visible first and just ask the person that has the card if they would be willing to measure the few pins that are unknown, that's basically what I'm doing, but it's, we can make educated guesses about the other pins while we're going. So top left, yeah, definitely that one for sure next. Yeah, I think I actually need to take a rare bathroom break here though. So I will be back in a moment. Trying to think if I have anything interesting I can point the camera at for a little bit here. How about I just show you guys the CD drive for a bit? So, yeah. Did you save the file? That's a good call as well. I will do that. Turn that. Yeah, I normally try and avoid taking bathroom breaks during stream, but this time I do. Not like a super emergency, just I need to. There we go. Look, fancy pants CD drive. Woo! Think you're gonna take a sleeping break? Whoa, yay. All right. I'm gonna go click all the things and click save. Click save. Click save. Okay, everything's saved. I will be right back. Mic is all like hardwired to me. So, one moment. Okay, I am back. Looks like a proper CD drive, yep. It is a very cool looking CD drive. That is for sure. I'm not gonna bother with the full fancy route for my mic this time. Oh. Alright. Hope you got your fill of it. Ooh, look, it opens too. I don't know what the run button's for. That part's a little confusing to me, because the CD drive, or the computer, I say, should initialize it doing stuff. So, yeah, I don't know. But yeah, that's the thing. So, all right, let's get back to reverse engineering the correct card, not that one. So, boom, laptop. Is there a teardown or something of this vintage? I think there is one person who has one of these who got a different card working with it, who has like a thread where they tore it down on Vogons. It does. I don't think it can do CD audio at all. Because this card this is the original card, does not have audio out, and it does not have RCA jacks on the back. I don't think it can do CD audio. It may not even be able to read multiple tracks. I think it's really weird in its implementation of pretty much everything. So, all right, we have this back. I'm going to try moving the image. Oh, that was really slow. But that's about it. No, there are no RCA jacks on the player. No, I'll go grab it and I'll show you the back. There's nothing. It does not do audio. Nada. It's just the data port, the dip switches, which are apparently for the address, which I don't understand because it's a serial connector. It doesn't have it's not a bus, so I don't know what you do with that. And then there's that, which that's a thing. So yeah, that's it. So Jack of Clubs, the way CD drives work is there are two ways you can play CD. The CD drive itself can actually play the audio directly out of the back of it. You might remember way back when you'd set up a computer with a CD drive, you'd have to plug the cable from the CD drive into the sound card. That's a CD drive just directly playing CD audio like that, and it works the same way that a CD player does. So the computer itself doesn't actually get involved in the audio quality. Then some computers would, later computers would be able to read the audio data through the CPU and actually process it and then play it back. So there were some computers later that would do the same thing, or that would actually be involved in the quality of the audio, but initially they shouldn't have been. So this drawing of how I'm guessing the card will function block diagram. All right, I'll take a look at that. Yeah, that does make sense. Address decoding, UART. Yeah, that makes sense. I've got a little headache brewing right now. See, so I have an old CD drive with all the audio controls in the front. Yeah, see, that doesn't involve. You could connect power to that and then have an adapter cable to use the audio connector just straight out to a headphone plug or something, and then you can use the buttons on the front and just have it play CDs. No computer needed. Yeah, I'm a cat. That's the thing, is that there were CD drives in this line that just added straight up features that was seemed like they should have been there. Drink more Linode branded water. Yeah, it's not that, and then I'm gonna have to pee more though. I don't think that's what the headache is. It's actually probably staring at the brightly lit wall behind my computer that's doing it. So I have lights on the ceiling pointed at the wall to reflect softly back at me, so I'm lit, and it's just white. So that's probably more what it is. That, and then maybe still lingering symptoms from COVID. That's very, very possible. Headaches from that are a thing. And this feels like a different kind of headache, so could be that. All right, 138. It's that thing. Wear sunglasses. That's a little hard with the monitor and the polarization. Okay. Yeah, that part, the light part kind of sucks. Okay, so bringing back the 138 schematic, which is still bad because archive.org's PDF viewer is annoying. So, just upgrade to a CRT. Well, that doesn't help. I don't know if you drink coffee. I've already had a sufficient quantity of coffee today. Any more would be negative effects. So, yeah, no, not on the coffee. That's not it. All right, so trace. Oh yeah, still a rectangle. Okay, ground there, power there, and they've already been done on the schematic. So the address jumper controls the I/O address and the ISA bus, like the first serial port used, some or another. This we configured to 300 through those. Yeah. Classic sign of caffeine addiction. Okay, so we're thinking pin, what was that, 6? 1, 2, 3, 4, 5, 6 is just low. So pin 6 here for logic E. Let's see. Oh my gosh, archive.org. Seriously. How about one page at a time? Ah, here we go. I found the secret to it not sucking. Oh, unless you scroll all the way to the bottom. Okay, so pin 6. Because it looks like pin 6 is tied high. That's what I'm looking at here. Pin 6, E3. E3 is an input that is not inverted, so they're basically just having that input always be high. So, okay. We will connect. 6 high can be good. Okay. That's what it was looking like. Okay, so this, copy. That's ground. How did I get ground? Copy, paste. Boom. All right. Then I will come over here and kind of that. See, E pins are enable. All must ultimately be true for outputs to be enabled. Oh no, is it that horrible chip again? Oh no. Oh no. All right. How about on this? What did we decide? So I guess that no connect is acceptable on whatever that one is. That's 7. Yeah. So we decided a no connect on that was acceptable. So 9, 8, 9. Yep. And then 10, and then 13. 9, 10, 11, 12, 13. 13's actually connected on this one, it looks like. Hello, Jout. Okay, but we have no connects on 7, 9, and 10 by the looks of it, which matches some of what we have going on there. 9, 10, but 13 seems to be actually getting used. Yeah, I mean, Jacotech, we had a whole other thing going on earlier with those ones where I've just, it's they're not clicking for me with this schematic. So, yeah. Board is just 2 layers, 1010. So that makes this possible. If this was multi-layer board, not gonna happen. Okay, so this is 9, 10, 11. Going off to a touch point, which, hold on, is that going to a via? I don't think so. I don't think they put a single via under a test point yet, so I'm inclined to think that that's not. Oh man, this one goes off on an adventure. What was this again? This was 9, 10, 11. Okay, so I'm just gonna do this real quick. All right, back to this. Let's see. How's the card coming along in the hour or so since it's been gone? From what I've heard, it's not gotten to the end just yet. No. No, we're still plodding along. Yeah, that connects to pin 2, whatever that is, 109. Oh, that's the first time connecting to a trace on that chip? Yeah, it is. All right. I think, well, okay, so here, Jout, a real, what are you using for the schematics? Over here, this is KiCad. Yeah, it's open source software. I'll be able to directly just make this into a PCB from this software. It's all bundled in the same program. I'll generate a net list, export it, and all that. So yeah, I like this software quite a bit, actually. So, but anyway, to answer your question, Jout, the chips here that we have marked green, if I flicker them a couple of times, it'll be easier to see here. Those are all done. So I'm working on that top left corner one next, and then we're about a quarter to a third done. And it looks like I have connected to one. Okay, 11 there. Yeah, no problem, Brian. Okay, 2, boom, This one's got to go long ways. Where was that 11 at? All the way down there. That is a gross routing. Whatever. Boom. Okay. Generate a net list, export it, no more. You can just import the part straight from the PCB editor. Oh, interesting. Finally. It's kind of dumb to have to still go through the net list. Okay, so 9, 10, 11, 12. See where this one goes. Oh no, it splits. Gross. Alright, so it goes to pin 1 on whatever that is. 13. This schematic's getting really busy up here. I don't like this. Alright, and then where was that? This. Okay, and then it also goes wherever this is going. That is a long, long trace. That was one of the 595s for some reason. Okay, so that goes to pin 16, 17, 18. Oh my gosh, I'm bad at counting. 16, 15, 14, 13. Pin 13 on the bottom 595. Output enable. Why? No, don't ask questions I don't want answers to. All right, let's just connect it. Boom. Boom. Okay. Line from 11, the line from 11 did connect to the other line. Line from 11. Wait, what? Did it? What do you mean? 11? Did that have a split too? 9, 10, 11, okay. Well, I'm gonna follow this without that. So you're saying that this connects to something else somewhere? It's not that. I guarantee it's not that. There's no via under there. They haven't put a via under a test point in any other location that I can tell. So it goes off. Okay, there's no split there, so I don't think there's a split. Oh, and KiCad? 11. Let me check that. Did I accidentally add a split? Wait, what? Hold on. Where? Oh, did I over? Oh no, I overwrote trace. Great. Oh, thank you. That's a very good catch, Dutch Black Cat. I'm gonna have to undo a bunch. Yep. Too crowded. Okay. What just happened? KiCad just crashed, I think. Oh yeah, it's great software. It crashes real good. Oh my gosh, if it crashes, depending on what it saves. It may have just saved the corrupt pins. We're about to find out. I don't actually want it to have auto-saved there. Well, this is potentially embarrassing. It appears the last time you were editing, one or more of the schematic files were not saved properly. Do you wish to restore the last edits? Sure. Couldn't be renamed. Error 0 success. Okay. Following automatically saved files cannot be. Okay. Where am I at? 11 and 12 are not done. Oh, cool! It did that bug. Yay! This is not KiCad's fault. This is KDE's fault. When you move a window in KDE, all right, it becomes slightly transparent, so you can see what's under it. Kind of cool. You can align stuff a little easier and see where it's going. But there's a bug sometimes where it stays transparent. So this window is just now transparent. And this bug gets even more exciting. If I close this window, it will just stay there. It will never clear. The window buffer is just tainted, and it stays on top of everything. So this window is now poisoned and transparent. So what I need to do is I have to close this, but I can't like have it be full screen because then it just ruins that whole monitor until I restart. So what I'm gonna do is I'm gonna make it as small as possible and stuff it down into like a corner. Like I don't use that corner as much. Nope, not that. And then I'm gonna close it, and then you'll see it'll just taint that corner. That corner is gonna have that in there. Boom, closed, and then it comes back. There it is. I can't. Oh wait, yeah, it's probably cropped for you. Yeah, you can't see it. But yeah, there we go. So now I can open that again, and then it'll be back. And yeah, I have no idea what causes that. It's just sometimes it happens. KDE is good, actually. It's just that's a bug that I have happen quite a bit. I don't think I've only ever had it happen on this laptop, though, so it might be something to do with the NVIDIA Prime nonsense. Can Xkill get rid of it? I don't know. I've not tried that. I'm not really sure. So, all right, it looks like we need to redo 11 and 12, and that's it. So I think it kind of crashed where we were. So I can just move these. Hey, look, it didn't crash this time when I did that. And then we're good. Is he using Compiz? Not with KDE. KDE is different. Compiz is genome only. Compiz, this has most of the effects built in that you like from Compiz, like wobbly windows and, you know, the desktop cube. Apt to uninstall transparency. I might be able to disable the window transparency, but then what will happen, I suspect, is that the window will just become unkillable at some point, and then I won't know because it won't be transparent. So for right now, I prefer it go transparent. Because then I at least know, oh, this window is now bad and I need to move it away. So, all right, pin 11. Let's redo the tracing here. 9, 10, 11, okay. 11 goes to 1 on 109. Where is 109? Oh, it's way up there, man. Or is that pin 2? That's pin 2. Let's do this correctly. Okay, there's that. 11. Clean. Okay, I'm going to try to start remembering to do that, running or viewing the net after I place it each time. Manjenko Tech, I have information about that down below. You can look at my Linux bit in the description. I actually added this morning a bunch of panels below the stream with information about stuff, and I have a section on Linux that specifically covers what you just mentioned. So yeah, I just posted on the Sure channel on Discord about 12 Nixie tube calculator. Ooh, that's cool. Did you get it, or is it for sale? But Nixie calcs are always going to be awesome. All right, let's look at 12. Watching on the TV so you can't see any of that? Oh, okay. Basically, it just says I won't use any other distro other than Ubuntu. That's all. All right, 12 to 1 on 713. 713. For sale, eBay UK. Okay. All right, 12 wire. Okay, let's not overlap to 1. What was the key for this? Oh, it doesn't actually say. Okay, but it did not overlap. All right. And I think it went to output enable on that, so pin 13. Oh, okay, Jacotex, you're just trolling. All right, got it. Let's see, 16, 15, 14, 13. Yeah, 13. So output enable. All right. We're about to be back to parity with what I thought I had done. There. Fixed. Okay. Save. Whoa. Does SkyCat have rat's nest display option that would allow you to just connect the pins with direct lines? Overlaps are going to get worse. I don't know. I don't know if you can do that for this. What I could do is just give each net a name. That sounds horrible though, so I don't think I want to do that. Yeah, I don't know if it has a rat's nest mode. The overlaps are going to get pretty bad. But so the other thing is though, is that I'm mostly done with this bottom section, so it should start lightening up a bit as I move towards the top. Thank you for the tier 1 sub, Blake, and for 7 months. Oh yeah, it is Sunday. Let's see. Okay, next up, pin, what is it, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 16, 15, 14, 13. So pin 13. Let's work on that one now. It looks like it has an adventure to go on too. A little mini one, not too bad. Or, nope, it's not done yet. Okay. Oh, it just goes to pin 1 on whatever that is. 11. That one's 11, so it goes here. Yeah, 11. Whoa. Nope, that's pin 1. Wait, 11? Hold on. Wait, what? What is that thing? A 125 that has like a side input to the gate? That's weird. How hard is compact portable 1 to power supply to find? There's one on eBay missing it. That is super strange. Yeah, it's totally proprietary. You don't want to have to try and find one. You will probably have to recreate it. Side input is output enable. Ah, okay, that's weird. All right. There we go. Trying to make it so that I can actually like do this. Okay, so this is 13. If I go there, I can sneak it down into there without overlapping anything. And check it. All good. Yeah, so see, recreating stuff is easy. Yeah, yeah. Well, I mean, if you can just make a power supply, it'll be a lot easier than trying to recreate the original power supply. That's a whole other thing. I have made just power supplies before. That's not too bad. I am gonna do this. Grab. Let's just shift all of that over and then fix that disgusting trace. We're not doing that. All right, space freed. Let's see. Problem is, need to know the voltage, as in someone measuring original input voltage. Remember, well, Stefan, it's a PC, so it's probably just -5, 5, 12, -12. So it's probably not that hard. Okay, 13's done. 14, 15, 16. All right, let's do 14. The monitor might be weird, but it could also very likely just be normal. Okay, this one goes, uh-oh. Well, oh, actually, I think I can see it goes under the cap there to here, and now it's a mystery one. Cool. All right, so we have our first mystery trace going into, actually second mystery trace going into the UART. It is probably going here, but we don't actually know. There's no real way of knowing, so we just kind of have to assume. Because yeah, that lines up with that via, and just hope that it's not weird and doing anything that it shouldn't be. I'm gonna go ahead and do that, and then we will go back to green and go here. So that is 13, 12, 11. Okay, so it is 14 to 11 on the UART. So 14 going all the way up to the UART. So you know what, we can go out and around. Let's not crowd this area more than we need to. No, not that. All right, where's 11? Of course it's on the other side. All right, you know what I'm gonna do? I'm gonna grab all of those plus this and lift them up, so I can put ground there later. Jout out asking them if they have the bad power supply, because it'd be way easier to recap one that's bad than try and replace it entirely. Of course, it's possible that it was also just chucked, but yeah, you never know. All right, pin 15. Going under a capacitor there. Coming around to pin 1 on 12. That one's pretty tame to route compared to some of the other ones we've had to deal with. Double check, I didn't get anything mixed up. And it looks good. You know, same with that one, doesn't hurt, just be sure. Yep, we're all good. All right, that chip is, where's pin 6 going? Is that one no connect or what? 1, 2, 3, 4, 5, 6. What? Oh, it's just tied high. Oh, I lost that. Oh, okay. Copy, paste. That was one of the things lost when it crashed. Okay. Hopefully we didn't lose anything else. Still, it's portable, so foam and foil. I've had enough of that with my Dasher D200 now. Yeah, definitely don't blame me there. Oh, wait, it's 20 pounds? Oh my gosh, buy that thing. That's worth it for the weird CGA card alone. If you can get the CGA card for 20 bucks, it's worth it. Also, the floppy drives, there's some value there. I mean, I'm not encouraging you just scrap it, but, you know, I mean, 20 bucks, that's a pretty good deal. Yeah, I can mark this chip as complete. Boom. Oh, look at that. Greens. Oh, so you'd have to ship it. That would be not fun. All right. Can't decide if I want to do the 595s next or not. So I feel like those are probably way more complicated than I realized because they're so integral. How does pin 6 get to VCC? That was one of the ones we looked at before, but it just jumps straight up to the rail that goes under the chip. So it's right here. Pin 6 just goes bam right onto that thing, and that's the VCC line. The bottom side is ground. So all right. Lower rail, yeah, lower rails are ground. So here it is connecting to there, and then that was ground on the bottom side. Whoops. So yeah, ground here goes to the bottom rail. And then we can see VCC goes to the top rail. So, yeah, that one's done. Which one makes sense to do next? That's probably power, probably ground. So we have 1, 2, 3, 4, 5 pins left on the first 595. 1, 2, 3, 4. Wait, what? Number of pins I don't have connected here don't match up with how many pins are left over here. Everything is connected below pin 8. Yes. Okay, pin 9, not connected. Pin 10, not connected. Pin 11, I have marked as connected. No, that should go to that one. And then that doesn't exist because it is connected on the secondary chip. Okay. And then here it goes down and goes into the 32 down there. Okay. It's looking very similar to the circuit designed for interfacing UM245R USB serial parallel interface module to your Amiga 500. This just seems to have a few more buffers and status signals. Well, that's cool that it's similar to an existing design. I'm not familiar with any of this. This seems really complicated for me, to me, for just a serial card, basically. I'm guessing all the buffers and stuff is because there's just slightly different logic levels, like 5 volts to the computer and then 12 volts to the serial thing. And I guess I'm just used to the future where the serial translation all kind of happens in one chip. I've not done any 74 series logic PCB design, actually, now that I think about it. I've all done digital logic. Well, this is digital. Programmed logic. Okay, so that now matches. Oh, I did that. That was dumb. I messed this up. This connects to 13, this connects to 11, and that's serial clock, not that, but I'm now going to reconfirm that. Serial clock goes to input 1 on 7. Okay, so 13, blah, 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 blah. Input 1, okay. Wait, no. Definitely not. Because, what do you want, eBay? Ah, stuff shipped. Nice. Okay, honestly, it was pretty standard for any comms card. There's too many differences in timing with the UART to make sure that it doesn't interfere with other processes. Also, you run data transmission errors because CPU can't service support quickly enough. UART interface with PC Junior is notorious for exactly the reason these designs are needed. Ah, okay. Interesting. Something's wrong here, though. Oh, wait, no, that looks like it's right. Okay. No, that's good. Okay. So that's correct, but it doesn't go to the bottom 555 or 595. It goes to the top middle. So I should just do this. There. So many little mistakes. I really hope I don't have something that's egregiously wrong. Ugh. One nice thing that I will be able to do, and assuredly will be doing here, is once I have Gerbers, I'm going to overlay the Gerbers on top of this, so I'll be able to see if there's like traces that should be going there, and then just go off to somewhere totally wrong. So I'll have some kind of built-in sanity checking for when I actually design the PCB before I order it. So, oh, excuse me, at least there's that. Oh, man. What is this thing? I think I'm going to do whatever this is. I've decided this is next, whatever this is. This is 706. Okay. We're doing this one because I feel like it. 706. Okay, so what do we got? We got 4 inputs left. So we got 2. Where's 2 go? 2 goes somewhere. Let's find out where somewhere is. Let's do that and then this. And now I can draw. Boom, boom, boom. Okay, we're finding 2. Where does 2 live? 2 goes really far away. up to, oh, 2's complicated. Thanks a lot, 2. All right, 2 goes to 708. And it goes to what, pin 3? That's an output into an input, so that checks out. All right, but it doesn't have the decency to stop there. So we have to continue, where it then just clobbers straight through the next pin, which now I got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 7, 14, 13, 12. Yeah, so it goes from here to 12. And then this goes, wait, does it just go straight over to there? Is that it? Yeah. Okay. So it just goes bam right through all those. So pin 3 on 12 here also gets it, whatever C is. Sure, why not? So there we go. That one got complicated. Boom. That looks right. Recreated again in a Logisim to test that it functions. Oh my gosh. Are we also going to review the schematic for we are also going to review the schematic for obvious errors. Yes, for sure. Check all the blocks that are separate logic units, go to the correct things like inputs to outputs, outputs to inputs. So, yep. See, which chip was I doing? I don't even remember now. This thing, 706. Where is it? There it is. Okay. So that was pin 2. Cool. Now we got 12, 13, 11. Where are these ones at? Okay, so there's some there. So this is a 1, 2, 3, 4, 5, 6, 7. So 14, 13. 13 goes somewhere, 12 goes somewhere, 11, yep, we can get them all. All right, this one's pretty simple. Start here. This is 11, goes up, squiggles around that via because it felt like it, I guess. Goes way up there. We goes to that via, hopefully. Whoa, let's not rotate it. Goes over to here. 2 pin something. Boom. That was, oh no, now we're not doing a crooked trace. No, we're not doing a crooked trace. No, I said we're not doing a crooked trace. Okay. 1, 2, 3, 4, 5, 6, 7. So that's pin 13 on 12. So that was 11. To pin 13 on 12, which is an input, it looks like. And that was an output, so that makes sense. All is right in the logic world. Oh, I screwed that up. Let's try that again without it being dumb this time. Thanks, KiCad router, for allowing me to just put the trace over there and then it like snaps. Like, so you go out, it's like, oh, I'm going to clear the traces, and then you accidentally go over it, and then it just locks you there. And then you, by that point, you might be over here and not even notice. Anyway, enough being cranky. Double check. All good. My favorite Pavement album, Crooked Trace, Crooked Trace. All right, now we got 12 and 13. Where did 12 go? All right. N. That's why you never use KiCad. I find their trace routing to be not the most ideal. So, why does that touch a via? I don't like the via. Oh no. It's not that bad, Manjeko Tech. I mean, it beats the other options. Although I kind of like dip trace a lot. but that's a different thing. Let's see. Why does that not just do a 45? Oh yeah, because dumb auto router. Okay, so that connects to pin -3, 1, whatever that is. 1, 2, 3, 4, 5, 6, 7, 8. So 16, 15, 14 on 9. So that was 12 to 14 on 9. Boom. Okay, that was all kinds of wobbly. And I screwed it up. You kidding me? Seriously? This is the last chip. It didn't save 2. KiCat's been really stable for me, so this is frustrating. Yeah, well, I should. It's, I should have put more space in there at the beginning. It's gonna take some work to do that, that I'm not gonna do on stream, because that's gonna be a lot more effort, but I can do that. Alright, where did 2 go? So lost probably 2, yep, and 11. Oh, 2's the messy one. 3 on 8. And it goes to 13 and 1 up there, I think. Or is it 12? I think it's 12. 14, 13, 12. Maybe take a break after covering. The break is going to be ending the stream. We're going to be ending the stream after this chip. So that's what it'll be. I'll be taking a break when I drive home. Yeah, it's been long enough here. And then it goes over to pin 1, right? No, pin 3. That's familiar. Yeah, it's been long enough for today. Pin 11, where did that one go? 1, 2, 3, 4. You know what I should really do? I should go through and number how many pins each chip has, just so that I can stop having to count them all every time, because the difference between 7 and 8 is imperceptible. 1, 2, 3, 4, 5, 6, 7. Okay. So 8, 9, 10, 11. 11 goes real far away. 11 goes to whatever that is. 1, 2, 3, 4, 5, 6, 7. So 13 on 12. Okay, make sure it's not messed up. Click. Save. Just know all the 74X logic chips and the pinouts. Yeah, really. Okay, 12. Yeah, saved. Definitely saved. Okay, this was 14. 14, 13, 12. Okay, 12 goes to pin. That's 16, 16, 15, 14. Goes pin 14 on 9. 12 to 9. It's way up there. To 14. Okay, we're going backwards this time because I feel like it. No collisions. Okay. Portable sold for $162. Oh, wow. Paste the pinout of each chip over the chip in your image. Well, so Manjeko Tech, that would be kind of nice, but I'm trying to keep the file size down because I'm like right up against the edge for GitHub. Like it is, how big is it right now? It is currently, oh, only 53 megs. Okay, maybe I could add a layer that's a bunch of reference material. I don't know. Anywho, 13, last pin. And then we're calling it for today because I am very clearly fried. Okay, 1 goes to there. That's just a test point, and then it goes to hooray, a guest trace. Which one of the two is it? Okay. Actually, there are a ton of options there. Oh my gosh, this one's horrible. Oh, yeah, really, Brian. This could go straight down and connect to that. It could go up to that one. It could go up to that one. All right, so process of elimination. There's probably not a good reason for it to go there because it would just go there on the other side. So we can eliminate that, and it almost certainly doesn't snake around to that one somehow like that. So it's probably not that one. It could theoretically do that still. So that's fun. They've definitely done some like complete turnaround angles. Like here's one where they go up and then back. So it could totally be that. Or it could go up to that. Wait, we marked that chip as done. It's not done. We haven't done this trace. I don't have the card, Brian. I don't own this card. That's the whole point. I would not be recreating it if I had it. There's only one person I know of who has this card, and they're in the Netherlands. Yeah, I'm not doing this just because I feel like being nice and want people to have the card. I just don't have the card. We only have pictures, and I can ask the person who has the card to check some things for me, but I'm not going to do that until I have everything else done so I can eliminate as many questionable traces as possible through the process of elimination. Just move. Netherlands are better than the US anyway. I'm not necessarily going to disagree. All right, let's think about some stuff. This goes straight down. It would touch that. That kind of makes sense. Then this could go here like that. So that would mean this goes to there. Does anything else make more sense than that? What does that trace do? That trace may go to there. It's probably not, because it looks like that's just the flux shine. So that one just goes to the resistor, and which goes a whole bunch of different places. All right, so this one has a trace. This one does not have a trace. That one is probably just connected to there. That one, no trace. That one has a trace, so that one's isolated. That one is definitely no connect because there's the ground rail, so that one is nothing. That one, we know, we could be very, very confident that one is either no connect or just like directly connected to that thing. Where was that one picture? This. So I'm looking at, yeah, it is that, right? Pretty sure it's that thing. Let me double check. Second in, third up. Okay, so second in, third up. Yeah, so those are not connected. Ooh, those top two are connected. Hello, that's a thing. So that would be tying that to ground. Why would you go that way instead of straight down? That does not make sense. I don't like that, but that would answer that. So that's connected. That one has a connection, that one has a connection, that one's good. Okay, so no connect on there. That connects to that. This also must be a no connect. So this is 74. Let's go back to the data sheets. So 74p. Is that an input that goes to that output or something like that? Oh, a flip-flop. Cool, I have no idea how this works. All right, fun. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So our 6 and 8 things, 6 is an output, 8 is also an output. So if they don't need, are those inverted outputs? Is that what that is? Okay, so if they don't need the inverted outputs, that could make sense. So 5, that one's connected to something, and then 9, that one's also connected to something. They both go down, so that could kind of, well, if that one goes to that, I'm hoping that one goes to that, and then this one goes up. So that, again, that makes sense. Those don't connect. Okay. All pins have visible traces. The only questions, flip-flop, 4 inputs, 2 output, one of the outputs is needed as minimum. Yes, and I'm thinking it's the non-inverted. I think that's what we said that the line was for, is that's an inverted output. So those are not connected. So theoretically, let me grab some yellow here. This could go down here. This could just come like straight down to that. And this could go up to there. There is no business for any of the traces to be going to any of the pins under the chip. They're all just going different directions. triangle is inversion on that design of symbol. Okay. So the only thing to be concerned about are alternatives. So let's say there are two parallel traces. We know there are parallel traces under there. These cannot cross. So it is impossible for this one to connect to there, because then this one is orphaned and we know it doesn't go to anything over there. So this one must go past that, which means that the only place that can go is right there. So that must go like that. Now, there is no room on the outside of that trace. So this has to go on this side, but this could still connect there like that, and then this could connect like that. So that's the only real questionable thing, is whether or not this one connects to that or it connects to that. Either one of those makes sense, but it kind of makes more sense for it to just go straight down. But we don't know. I don't think there is a way of knowing unless we get context later. So I'm gonna go ahead and delete all of that for right now, because either one of those could connect to either one of those. But the one that I was actually trying to figure out, we do have an answer for. It goes up to here. Oh, and then it disappears under that ship. Oh, are you kidding me? Oh. Okay, so this one, we know it obviously goes like that. So then we have yellow trace again. Okay. We have a bunch of red traces there. All right, so it definitely doesn't go underneath. I think we know it doesn't go to that via for sure. It could go to that one. But let's see. These are connected for sure. So that pin will, what am I doing? What's this? Okay. The 32P, I think we have that open somewhere. 32, okay. That's ground, right? Pretty sure, or power or something. Yeah, that's power. So that connects there. That's guaranteed. That is not ground. That is ground. Why does that go up there? Oh, so they could decouple. Ooh, so they could couple that cap. Okay, that makes sense. So I'm not going to mark that one, but we know that goes there. So, okay. This pin taken. We're not sure about that one because they're decoupling. That is not an actual signal. So it could, this could come up and go to that pin. That's a possibility. One has a connection right there. So one has a connection. 74HC, when C1 clock goes high, the value on D1 data is stored and reflect on the output and inverted on the other output. SR and reset to allow predefined states. Okay, so, but that tells me that those outputs are the same, they're just one's inverted, so if you don't need the inverted, you can just chuck it. Okay, so maybe on that one. Taken, unknown. Taken. Okay, so this could theoretically come up to, no, I want yellow, hold on. This could go up to here and either go to there or go to there, because we don't have an actual signal going into that, it's just a cap. So we have here 3B and 1B. 3B and 1B. Okay, if I come down, 1B to 4B are data inputs. So, okay. Is there a logic block? I have to say, this is by far the worst balloon anvil I've ever seen. Yeah. Okay, 1B goes to there, 3B. Okay, so they kind of both have to be connected or grounded. This is OR. Okay, so it wouldn't be tied high there. This wouldn't make sense to be tied low. Why actually, why is there a capacitor there at all? That doesn't make any sense. Are they decoupling that, or are they filtering it so it's smooth? Is this like a really fast clock signal or something that they're trying to make stable to tell when the clock is active at all? If that were a resistor, it would make sense for a pull down. But it's not. It's a capacitor. At least I think it's a capacitor. Oh my gosh, you know what? I messed up all the colors. Is that a resistor or a capacitor? That's like slightly green, although everything's slightly green. So I guess that's a cap. The other side of that just goes straight down to the ground pin. I don't see any other way for data to get to that input. Wait. It's got to be that. It has to be that. This is connected to here. Okay, those share an input. Boom. We got it. We got it. We got it. It has to be... It has to go there because... This is a trace right there. Go over to here, confirm. There's the trace. So it must go to that smooth one, with the filter capacitor. Okay. All right. Let me really quick do a couple of things here. So this is 12. 12 connects to 11, 10. Which means I can actually do that. Okay, so we have that one marked, which means that I can now do this. Okay. 2 is an input, and that goes to, this is very, yeah. 2 goes down to pin, what was this, 7, 8, 1, 2, 3, 4, 5, 6, 7, right? Yeah, 7. I lost it. This is 13. 13 goes to 2. Oh my gosh, I'm about to have it. Check for no collisions. We're all good. That chip is done. Oh man, really enjoying this kind of stream. I'm glad. That was a kind of fun deductive process, I will admit. I enjoyed going through all of that there. That was actually, as much as I was like just I enjoyed that. That was kind of fun. That was a puzzle. I enjoyed that puzzle. Techno Junkie 88, hello, since your first time chatting. Can you do high-speed designs? Does it have signal integrity features? It does. I don't know how to use them, but I know it does. They've actually done a lot of work on that. If you go on the KaiCad Twitter page, you can actually kind of scroll through and see some of the history of the stuff they've done. They have, like, I think they can route multiple pairs at once. I think they can do trace length calculations. I don't know about, like, mirror, or yeah, is it mirroring? Reflections, that's it. Like if you have an angle, I don't know if it'll measure things like that, but I'm pretty sure it has features for doing like matched lengths and things like that. So yeah. 106, so the one that I was working on, okay, 7106, pin 12. This is 14, 1, 2, or 14, 13, 12. What about 12? Did it not pass a via? What do you mean? Right? Yeah, it did. It goes up to the mystery one. Thank you for catching that. We have no way of determining what that is yet, outside of context. Do we want to just guess? Here is my guess. How's the progress going? Kind of well. I think I'm about to knock out one chip. Okay, so here's my guess. If this one connected to that, it would be higher up. There's no reason for it to be that far down. So I think that connects to there and that connects to there, because the positions would be swapped if they weren't trying to go past each other. The lines are too straight. We're just gonna go with that. Okay. Bleh. Yeah, I'm about to end the stream. What am I doing? I need green. Okay. So 12, here, 12. This one, the one that connects to 14. Also, what if you get it wrong? Dead chip. I mean, I'm going to be buying all these chips new. There's nothing vintage about this. As long as it doesn't send anything out that kills my CD drive, that's literally irreplaceable, then I'm fine. And I don't think it can do that. Progress seems to be going well. We all cheered for something, and the lines were drawn in green color, which is better than yellow. Yes, green good, green good. Yeah. Green means I can see the trace. That's basically what it means. Yeah, 4 hours. Yeah, yeah. What was I doing? Oh, yeah, it goes to this. Okay, so this is a 1, 2, 3, 4, 5, 6, 7. Okay, so 8, 9, 10. Goes to 10 on 13. So 12 here goes to 10 on 13, which is there. So, meh. Okay. Save, click, save. All right. We can call that chip done. However, we have to, oh, we can call that chip done too. I was gonna say we have to revoke done status on that chip, but actually no, we can call that chip done. We just have to draw one more line. From here, boom, boom. Well, let's actually draw a line though. Okay. Boom, 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 boom. There we go. I kind of want to finish that one just so we can say the bottom 2 rows of chips are done, but that's part of the 595 bus, which is really complicated. So that's like a whole other thing. This whole area down here, whole other ball game. That's way more complicated than everything else, and they're all done. Yeah, chip done, take break. Yeah, we're ending stream now, so that my brain can finish liquefying. And then later on, I'm probably going to work on this more off stream to finish up that whole corner. That corner is not going to be too big of a problem, I think. Who knows? Let's see. We got more wonky vias there. Oh, there's a whole bunch there. I hate that. That makes me want to cry inside. And then we've got no vias, some more vias. Yay. So yeah, there's some fun stuff. How'd you set up your PCB new to show the circuit like that? What do you mean? This? Or over here? So Techno Junkie, this is GIMP on the right side. This is just GIMP. So I'm not actually routing traces over here. I'm putting traces, I'm drawing lines over the tray. I'll back this out a little bit. I have 2 layers. One is the top side. It's just to scan a photo of the board. Then I have the bottom side, which is another photo of the board that I've made red, and I'm using the additive overlay feature in GIMP so that the dark areas of the PCB are not shown and the bright traces are. So I'm getting an X-ray view, essentially, of the board by doing that. Then I'm drawing lines, green for visually confirmed traces and yellow traces for I think this is how they go traces. For everything as I route them in a schematic into KiCad's schematic editor. So yeah, so this is just an image editor. That's why it's different. I have a histogram and yeah, other things. So I could maybe import images into KiCad. I don't actually know if that's an option. But I'd rather be able to draw right now just because it makes my brain hurt less. So yeah, that's the thing. So we're about 8 hours into this project, by the way, for those who want to keep score, without counting what I've done at home. So I probably put in like 2 more hours at home yesterday, I think, doing the bus routing stuff. So thought this was a new feature. No, this would be a nice feature. They may have this as a feature, I don't know, but being able to do random colors, like I have purple up here for just raw guesses. Like I think these is how these ones go. I don't actually know. So yeah, but it would be cool if they had a reverse engineering thing like this. I don't know that they want to specifically cater to the reverse engineering crowd though, because you're never reverse engineering something you own all the rights to. So there's not a whole lot of reason to add a feature like that from a legitimate standpoint. So yeah, well, I think we can call that it though. Let me save that, close this. We haven't done anything on that we need to do. Quite the undertaking. Yeah, I knew it was going to be a pain. It's slightly more of a pain than I thought. That's how it goes with these kinds of things, though. They're always way more complicated than you think they're going to be. That's why, you know, time estimates for stuff like this are kind of a joke. All right, so git commit more chips finished. Boom. Brain no hurry as much. Yeah. Git push. All right. So for those who are watching this, I have a GitHub repository where I've been putting everything in as I work on it, and it is now, as of in a couple of seconds here, I guess, gonna be up to date with the changes that I've done here in the stream. So if you want to take a peek at some of these things, you know, you can do that. Yeah, imagine trying to reverse engineer something newer. Honestly though, like that, I think it'd be easier. There's fewer chips on newer things. There's not as many connections. I mean, unless you got like a BGA that's got 100 pads, so that's something different. So let's see, this is larger than GitHub's recommended file size. That sounds like your problem, GitHub. So all right, now commit updated 1 minute ago. All right, so it's updated. Yeah. So the stuff is going up there. You know, does GitHub have a way of viewing? No, they can't view XFCs or XCFs. But yeah, you can go on to GitHub, check out the stuff. I'm trying to document it as much as I can. The reference images I've been using are up there, as well as my X-ray view that is also getting all of my annotations done. So yeah, let me move over to the other station. Yeah, the chat lag. Yeah, you know what? Hold on. We can fix that here. The problem is that the video capture is really delayed. It's just, it happens. So yeah, let's do this. Come back over here. All right. Who knows what code is on that CLPD? Yeah, that's a problem. If you have a modern thing that's got CLPD and it's like programmed into it, or you don't. Yeah, so that's another thing. I'm super lucky, all off the shelf chips. Like this is the CM-260 card. This is the one that I have. That there is a semi-proprietary chip. I might be able to get one of those if I needed to, but I don't think I could. So this card would be theoretically easier to do because we got, what, 2 RAM chips or something there, buffers maybe, I don't know. There are 4 ICs on this whole card. That's it. 1, 2, 3, 4, 5 ICs. So that's actually a much more simple card. I would much rather reverse engineer that one, but that one doesn't work, so there's no point in doing that. But yeah, that was a lot to do today. I massively appreciate those of you who have been watching and chiming in with like corrections, steer me this way, steer me that way, you know, different things to help me out, information about the chips, you know. So I don't know, Dratinio. I really have no idea. I haven't experimented with that kind of stuff before, so I don't know. Yeah, very much I appreciate the help. Really making it go a lot faster, and in some cases probably just preventing me from making mistakes that would require more board revisions after I get it made. So I really, really appreciate that. So I have a cool desk. This or the one over, I mean, I got a lot of desks in here. So when you say I have a cool desk, you know, there's a bunch. Like, there's that thing back there, which is my vintage PC desk, and then that's actually where I was working. This is my workbench. I built this, I have a video about it, but yeah. The one you're standing at, yeah, so I actually built this. It's designed to come apart into 4 pieces. The 2 upright legs are H-frames, and then you just undo 4 lag bolts per shelf, and it can be taken apart because I'm in a 2nd floor office right now, and this is where I do my soldering and stuff, and I needed like a really nice workbench. It's also on wheels, so it moves around. I have a 2nd one right there. I could swap them out, but I never have because I ended up wiring this one in, and that it was kind of dumb to build 2 now that I think about it, but oh well. Yeah. See, yeah, that's it, Harley Wogan. There's so many desks in here. But yeah, I will always stan the 2x4 and MDF desk, or workbench. That's kind of like the best way to go. But yeah, I like this for standing working. So yeah, the desk is the one over there. That's the desk as far as I'm concerned. That thing was a life goal achieved. I love that desk. So yeah. But anyway, I've been live for 4 hours and 19 minutes. We are going to wrap this up because I am totally brain fried. Oh my gosh, I want 3 naps. Yeah, you followed on? Thanks, I appreciate it. But yeah, yeah, this is a lot of fun to do. I actually enjoyed this whole process. It is kind of brain hurting, but it's also cool. I would rather do this than play Myst. I hate Myst. This I like. So, you know, yeah, I don't know. I'm enjoying it. Yeah, I'm now a desk collector. Kind of in a way, yeah. Amelgar Devor, hello, or thank you for the Prime sub. That's it. Man, my brain, holy moly. Yeah. Like you've watched TV for half an hour. Yeah. Desk phone collector. But I appreciate y'all being here. Let's go ahead and run the outro. All right, the printer's going. We're not doing that yet. There we go. All right. Thank you all for being here. Like I said, I really appreciate it and the help with routing this. I'm gonna do some more off stream. Probably gonna avoid those chips that got way a ton of vias under them. Do some easy ones so that I can knock out stuff that's not as hard. Yeah. Do we want to do this again Friday? Like, are we just going to keep doing this on streams until we're done? Is that the goal? Is that what we're doing? So, what's a via? The vias are the holes in the board where the trace goes in one side and comes out the other. That's a via. Need to ask you at some point about Python, talk over a serial port control and Extron device. It's not that hard. You can definitely do that. Do it. All right. Sounds like you guys just want me to keep on plodding along with this. All right. I will be taking a bit of a mental break from this over the week as I do some kind of YouTube video. It's either, I'm tempted to do the deck talk as a video because it's kind of awesome and I'm really having fun with it, even though we didn't hear it once today. It's been great, really enjoy it. So we might do that, or I might do that as a YouTube video, just talk about like, here it is, it's cool, I like it. Or I might do a mail video. I haven't decided because I got a bunch of stuff I really need to do mail videos on, and it's getting to the point now where they're starting to disperse into the office and it's going to be more difficult to do the video for mail stuff. So I kind of need to do it like before I start forgetting what actually goes into the mail video. So maybe that. I don't know. See, I love it when folks say it's not that hard. Nothing is when you know how to do it. I find this stream mind-blowingly awesome. Thanks for the great content. Not only text answers, but insanely brilliant chat. Yeah, big shout out to everyone in chat. Seriously, I very much appreciate it. So, yeah. So you met me at LTX 19. That's awesome. I've been looking forward to the next one, but life in the world has not helped make that happen. So, yeah. Yeah, I'm not as concerned about the eating as I am my brain being turned off for a bit. That is much more of a thing. So, yeah. Anyway, I appreciate y'all, and we are going to end this here. Kender has the right idea. End of line. So, if you enjoyed this stream, you might want to follow and check out the next one, which will be Friday, or you can subscribe on YouTube, where I try to remember to upload the VODs from the streams that are like a month behind now because I've been really bad about it. If you want to help support the channel, you can subscribe on Twitch, or find me on Patreon, or buy one of my merch shirts that are all at home to get washed at the moment because I forgot to do that yesterday because my brain was toast then. And what was the other thing? Oh yeah, but that's it for now, and I'll see you next time. I'm ready for a break.